How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking, we're hacking all the things. So let's talk about what we're going to be doing today. So the day is Wednesday, August 26th, and well, we're not going to be starting topic 1 with our Thinky Games Dailies challenges, because I need to do more challenges from Hacker Holidays. I want to finish off the series hopefully in the next 2 weeks, so I need to get on top of finishing those challenges. So we're going to be starting off with Hacker Holidays, then we're going to continue on into Hacker Holidays, and then we're going to take a little break for Linux OS operations, and then we're going to finish with Hacker Holidays. So there's a lot of Hacker Holidays going on today. But the good thing is that Hacker Holidays deals with a lot of different cybersecurity topics, so we get a nice variety of stuff that we're going to be looking at today. So without further ado, let's start into our first topic, and let's start our timer. So there's going to be 60 minutes on this topic, and I promised to get Waffler a redeem. So this is just for you, Waffler. Okay, so let's go ahead and get started. We're going to be working on this room first. It's called After Hours. Thank you very much, KK1 Darnock. Darnock, that's a pretty cool... Is that a reference from Star Trek by any chance? Let me know. Thank you very much for subscribing with Prime. Prime for you, appreciate your work. Thank you very much. And if you want to join Darnock, there's a little guide for subscribing with Twitch Prime. If you have Amazon Prime over here, I just left it in the chat. Thank you very much, Darnock. Much appreciated. Let's give you a fun video redeem as well. We'll give you the go-to hack, just like this.
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
I hope you can have a great day and go to hack. All right, so we're going to be doing After Hours over here from TryHackMe. Let me see if I can get the link for everybody if you want to take a look. This is a medium level digital forensics challenge, and I haven't taken a look at forensics challenges in a hot minute, I'd like to say. Okay, so what's going on here? And you know what? While we're doing our challenges, I might as well put on a little bit of music, because it's always nicer to have a little bit of background music. If the music is ever too loud, let me know, and I will definitely adjust the volume for you. Just my name backwards, I usually watch on YouTube. Oh, okay. I thought you were referencing, like Star Trek, Darnock and something something at Tanagra. Okay, let's get started with the challenge. So it's a medium level forensics challenge, and it says here in the description, long after the front desk closes and the pool lights dim, the resort's back office machines keep humming. Someone or something has been logging on during the small hours, well after the night shift technician has gone home. Darmok and Jalad at Tanagra. Yeah, that's the reference. Nothing obvious shows up in startup, scheduled tasks, or registry run keys. Whatever's keeping itself alive is hiding somewhere quieter, tucked away in a corner of the system most tools don't think to check. Okay, so we're dealing with Windows forensics. So I'm very, very bad at Windows forensics, and I think I might use the attack box to do this machine, because the attack box has all the tools that are required to do the challenge. So let me go ahead and start that up. So let's see, go up to the top of the room, click on Start Attack Box. Okay, and then after the attack box starts up, we can get started. So it says that session taken over, another browser tab opened this machine to take over the session. Click below to use this tab instead. Use this tab. Oh, I hope I didn't just get hacked. Okay, so let's see. PSA for anybody stuck right now, the usual auto runs persistent tools straight up don't catch this one. You're gonna have to dig through the raw data by hand. Hacker holidays. So we need to parse the provided system artifacts for hidden custom configuration data, locate the malicious class, and extract its embedded payload. Decode the payload, and submit the recovered flag. So this is going to be rough. Okay, we're going to put this in its own browser tab. And we'll exit the split view here. Guests working from the attack box will find the room's attachments already sitting in the luggage room. No need to check anything in. Head to Root Rooms Hacker Holidays 2026 After Hours. The bellhop's lockbox on the luggage is sealed with the passphrase After Hours Attachment Pass. Okay, so we'll navigate there as soon as we're initialized. It should be right now. Okay. So I'll just head to a terminal. And we'll make this a little bit smaller. A little bit bigger. Ooh, this attack box is not super responsive. Okay, so after hours.7zip, okay? Alright, we'll unzip it. So what is command to unzip 7zip from the terminal? 7z Linux terminal unzip. It's 7zx. So 7zx this thing. Oh, 7zx. Okay. Alright, enter passphrase. So we got the passphrase from the TryHackMe room here, so let's copy it. And paste it into the clipboard. That didn't copy. Let's do that one more time. Copy. Paste. Okay, good. Alright, looks like it's... Is it unzipping? I can't tell. Okay, it is. Awesome. Alright, so we've got a bunch of different artifacts. So after hours... Forensics HH. So we've got challenge attachments and tools. So what are these tools? IL Spy Linux x64 release and instructions.txt. Hey, Pretzel Pete, hello, nice to see you here. I saw a couple of your YouTube videos while I was browsing today. It's pretty impressive that you've got so many videos up, even though your channel hasn't been up for very long. I think you started your channel at the beginning of this year, if I'm correct, Pretzel Pete. Let me know if that's correct. This challenge requires a .NET decompiler to solve it. Instructions on how to run IL Spy. Unzip the tool, cd to this directory, chmod IL Spy, run with the tool, .il Spy. Okay. Yeah, no worries. I'm happy to support other cybersecurity content creators. Okay, so unzip all that stuff. And then it was like artifacts, like Linux, I think, Linux x64. And then they want us to run one of these, right? Let's take a look at those instructions one more time. cd artifacts Linux x64, then chmod plus x ilspy. I guess it's in this directory. And then run the tool with /ilspy. Okay, Pretzel Pete says I started doing soccer first, then transitioned to hacking. Well, I hope you're having fun. Regardless of what kind of content you're doing. Okay, so ilspy, this is a .NET decompiler tool. I guess this is what they called it. I wonder if we could run this on our own system, because it'd probably be a lot more responsive instead of going through the attack box. Let me take a look on the TryHackMe page. So let's see, download task files. Okay, and I guess these are just the attachments without the tool, but I'll take a look. Okay. So we'll call this holidays. This is day 12. And we'll move the zip file over here. I think it's called like attachments or something. Attachments, okay. Oh, there's more than one attachments. What was ours called? 36288. Okay, let's see. It's been good. I've been loving hacking since I was a kid, but mostly was study heavy. Now I'm documenting my labs. That's awesome. That's awesome that you're documenting the stuff that you're doing. Because, well, I mean, if you didn't document it, it didn't happen. That's what they say in cybersecurity, right? Okay, so we got our objects here, but we don't have the tool. So I guess what we're looking for is we need to find a way to get our own version of ilspy, which doesn't exist. Maybe we can install it. So let's see. So ilspy, not found. Okay. So it's probably a GitHub project. GitHub, ilspy, Linux. ilspy is natively compatible with Linux. Sure. .NET decompiler with support for blah blah blah. Okay. So I guess what we're going to do here is we're going to download the GitHub project, or clone it rather, and then run the tool from there. Let's see. Git clone this thing. Okay, this doesn't look exactly what we saw on the attack box. Okay, let's take a look at the documents. So how to build for Windows, and then for Unix Mac. You'll be back later. No worries, no worries. Good to see you here. Well, maybe, depending on like how many dependencies are required for ilspy, maybe we are better off using the attack box. Alright. So ilspy is working over here. And we've got... It seems like it's already got the stuff we're looking for, but I could be mistaken. Make a new terminal. Tab. Okay, so we got our artifacts, we've got our ILSpy release. And the actual attachments are here, so in challenge attachments. So we got index BTR, mapping 1.map, mapping 2 and 3, then objects.data. Okay, so I've never used ILSpy before, so I'm going to be warning everybody. I'm going to be asking the AI for a lot of help when using ILSpy, because I've never really used it before. So you have index BTR and then a bunch of mapping files and then object data. I wonder if there are any hints as to what to do. Cyberlock, hello, nice to see you here. Okay, parse the provided system artifacts for hidden custom configuration data. So forensics, Windows, persistence, reverse engineering. The only thing that they've got that we need to submit here is a flag. I love this. Really? Has anybody here used .NET decompilers before? Because I'm pretty clueless. Okay, so yes, but not a lot. Okay, so ILSpy, forensics, Windows logs, tutorial. Cairo Law, hello, nice to see you here. You can analyze .NET-based Windows logging your security utilities during a forensics investigation by opening the compiled binaries in ILSpy to inspect source code configuration strings, analyzing .NET binaries with ILSpy. Download and run the standalone portable version of ILSpy on your analysis workstation. File open the target compiled .exe or DLL files into the assemblies panel. Expand the assembly tree view to browse namespaces, classes, and methods. But SysOS Master, you must have tried out this challenge when the event was still going on, right? Did you have a good time with this challenge or not a good time? Let me know. Wait, did I close the thing? I thought I just clicked off of it. Mixed time. Mixed time? Okay, so file open. And I guess we'll open from up a directory, then up another directory, then up another directory, and we'll go to challenge attachments, .NET assemblies, all files. So we don't have a .NET assemblies file or packages. We just have these individual map files. So map files and data in BTR. Okay, I guess we can talk with our good friend the AI here and specify something. So we're not dealing with .exe files. We're dealing with .btr files and .map files. And what was the other type of file? .data files. Okay, during a digital forensics investigation, finding .btr, .map, and .data files means you're dealing with a database or a specialized application log, rather than compiled .NET code. ILSpy will not work here. Oh, really? Why did they suggest we use this tool then? As it only reads .NET intermediate language binaries. The combination of BTR, map, and raw, and data strongly indicates that you are analyzing a system running a btrieve something something database engine. It's commonly used in legacy enterprise software. Okay, so verify file types. Before parsing, confirm the file headers using forensics tools like TryD file identifier or a hex editor. Okay, well, I mean, I don't really understand, because the CTF challenge indicates that we're supposed to use ILSpy to do this forensics challenge, and has provided us with a Linux system with the Linux version of ILSpy to use. Aren't .NET files in a different directory, are they? I mean, I haven't done this challenge, so... So challenge attachment tools. So this is the after hours forensics.hh. I mean, it's the same thing in the stuff that we downloaded here. So these are the only files that we receive. So index.btr mapping 1 to 3, and then objects.data. Oh, okay. Gostu, I thought you were speaking from experience because you've done the challenge before. That context clarifies the exact setup. Those files, index.btr mapping and objects, represent a raw dump of the Windows management instrumentation. WMI CMI repository, traditionally located in the C Windows System 32 something something repository. Attackers use the WMI repository for stealthy persistence mechanisms, hiding malware configurations inside of custom WMI classes. Because the challenge explicitly instructs you to use ILSpy, a compiled .NET executable payload is hidden inside those raw data blocks. You must extract and decode it before ILSpy can read it. So search the repository for the payload. Since you are on a Linux CTF system, you can use built-in utilities to hunt for where the .NET code. Look for base64 strings. Attackers frequently encode .NET payloads into base64 strings, store them using custom WMI properties. Okay, I guess we can take a look. This stuff exists on our Kali box over here, so maybe we'll look for strings, because I'm pretty sure these are not... Yeah, this is data, and the mapping files are also data. And the objects.data is certainly data. Okay, so let's go ahead and pull out the strings for index.btr. I mean, this looks like hex code, not necessarily base64. Okay, so maybe not this file. Yeah, I don't see any base64 here. Okay, so that was the index. I guess we can take a look at the mapping as well. I guess we can get stuff that's only at least, I don't know, 16, length of 16 or more. Nothing here. Okay, how about 12? Nothing there either. How about... And then how about 8? Did you ask the LLM what the files could be for? Yeah, well, let me see if I can locate. Okay, so there's actually very little in this file. So the LLM indicated that there might be a base64 encoded .NET executable inside of the information here, in like mapping, well, in one of these files. So maybe in the objects file, as in the specific file names in the directory. I guess I can ask. If the box has Python installed, look for a tool like PyWMI parsing or equivalent tool to dump the structural objects. Take a look at the literal strings to spot custom class names or odd commands. Okay, I am really out of my element when it comes to this stuff. Okay, so what could these mapping objects in index file be? So what are the contents? What could the contents be? Was it like index.btr? Yeah. Objects.data. I'm glad I'm not the only one lost. Oh, I'm very lost. I'm very lost. Okay, these files make up the core database structure of the Windows management instrumentation, so WMI. Okay, so together they function as a custom relational database used by Windows to define, catalog, and what? Catalog and control system hardware, software configuration settings, and event actions. So objects.data is the database, the primary storage file for the database. It holds the actual content and records managed by WMI, split into raw data packages. It contains WMI class definitions, object instances, the payload and flag in your CTF context. The index. So the binary tree and the mapping files. Windows has a lot of standard stuff, so asking the LLM is a good intel thing to do. No need for ILSpy yet. You have to deal with the WMI first. WMI. Okay, so strings, objects.data, grep I for something to spot some unusual namespaces or giant blocks of base64 data. Okay, so I think we were going to get to that, objects.data. Alright, so there's a bunch of stuff, and I think what we want to do is we want to search for something that might be Oh, this is very hard to look at. We're probably looking for something that is a bunch of base64 data. Where could you be? Base64 encoded data? There's got to be some sort of regex that we could use to find base64 encoded data. Like, I've tried to do regex for base64 encoded data before, but it's never been satisfactory. There's a lot of stuff here. What's that? Maybe look for PowerShell? Maybe. Oh, like a PowerShell command. Oh, I see something. Thanks for the hint. Thanks for the hint, SysOS Master. Alright, so are these the same payloads? So PowerShell.exe, they're encoding, the encoded data is this. Okay, so I guess what we need to do now is to figure out what this data originally was. So this is probably our .NET binary. So what are .NET binaries? What is the standard file extension? So if we find encoded information that we suspect is a .NET binary, what is the standard file extension we should use? So .NET maybe? So the standard file extension you should use is .exe or .dll. So .exe or .ell. So I guess we would... So echo out this information and then redirect it into, I don't know, test.exe? No, we do not redirect into, we have to decode it first. Okay, echo into base64 decode and then redirect to test.exe. Yeah, it is base64. Okay, so file this thing. So this is data. So it's just called data. If we take a look at the bytes, file equals okay. So this isn't necessarily an executable either. Alright, well, let's... I mean, it's called data. I think what we need to do to turn this back into like a text file is just get rid of all the null bytes. So all the 00s. First we'll rename this thing. Test.exe, we'll rename this to test.txt. I mean, if we try to read it normally... Oh, we actually get something, okay. Okay, Telltale says they're hacking me. Who's they? Red Sly Fox, hello, nice to see you here. Okay, so there were two separate payloads, right? Though I think we grabbed the one that starts with JAB and ends with AA. But there were two. These are identical? It looks like these are identical. Thank you very much, Chai F, for following on Twitch. Thank you. So JABM, AG, at the end it's BSAA. Yeah, this is the same payload. So I guess this is more like a clue rather than an actual encrypted file. Because this is our PowerShell. Here, I guess we should pay attention to what's going on inside of the... Oh, there's a different payload. Is this a different payload? No, this still looks like the same payload. Hold on. Smooth cybersecurity. Hello, nice to see you here. What are you doing? This is Windows log forensics stuff. This is definitely not my wheelhouse. But we're trying out this challenge from Hacker Holidays, day number 12. If you are a person who likes to do Windows log forensics, you can take a look over here. So I just need to make sure that these are all the same payloads, all the same stuff that's being... Okay, so maybe we can... So grep PowerShell, then sort it maybe? Sort unique sort. So there's only one payload that's being run here over and over again. Okay, I guess we need to pay attention to what's actually going on here then. WMI class root CIM version 2 Win32 hard telemetry. And I guess this is where the base64 encoding would be done. But where would we find this base64 encoding? So new object. So D is a new object, O is a new object. Are they referenced? B is also a new object. So O and D, D.read, and then O.write. What is the file? So file is WMI class properties config data. So where are we likely to find this information here in the mapping and the index? Maybe we'll find it in the index. So look for like a pattern like this. Root CIM version 2. So we'll strings the index. Then look for that pattern with grep. Nope. How about just CMI version 2? Okay, we found something. CMI version 2 hardware telemetry. Win32 hardware telemetry. It's another pattern we can try looking for. Okay, I don't really understand the thing, but I know the more I watch, the more I rack up understanding cybersecurity stuff. I'm a noob, actually. Yeah, no worries. This is not anything that I really deal with myself on a regular basis, so I'm just as lost as you are. Okay, Smooth Cybersecurity says, how long will it take you to learn about cybersecurity? How long would it take you? I mean, are you talking about you as in people, or you as in me specifically? We're always learning cybersecurity. I mean, that's kind of the theme of the channel over here. Okay, so let's look for the pattern. Okay, that pattern was not found in index, and we're probably not going to find it in the mapping files either. And if we look in the objects, we find it a couple of times. So if we find it a couple of times, we can also get the lines around it, maybe the 10 lines around those. Oh, interesting. So this is more base64 data, and this is a much larger piece of base64 data. Let's see if we can sort this. So sort unique. And there's just one base64 encoded string that we need to pay attention to here. Okay, so this is a base64 encoded string. We'll just copy it. Maybe we can turn it back into its original form. We'll call it binary.exe. I don't know, very original. We'll base64 decode it. So what's in here? Data. Okay, sure. So is this... What kind of file is this? That's the payload, all right. I mean, it doesn't look like there are any strings in here that we can pull out. Okay, so maybe this is the thing that we're supposed to run dlspy on. It's compressed. Actually, okay. So my question is, how do you know it's compressed? I can't really spot the maybe something in the strings. You have the PowerShell. Okay, so the PowerShell. So compress. Okay. So the compression mode. I guess we could ask our friend what the standard compression method is, and if the compression, what would be the command to decompress this. Thanto says, oh, PowerShell deals with it. It's 6:30 in the morning. Hello, Thanto. Well, you must be in Asia. Are you in Asia? Although you don't have to answer if you don't want to. Okay, so we found this PowerShell command. If the binary was compressed with this command, how would we decompress it? I can tell you it's deflate, and that's a pain to work with. Deflate. So to decompress a payload that was processed using that exact PowerShell setup, you need to perform the inverse operation. The PowerShell command indicates that the original file was compressed using deflate and then encoded into base64. To reverse this on your Linux CTF machine, you must decode from base64 first, and then decompress using raw deflate. Oh, you're in Japan for vacation. Awesome, awesome, Thanto. Hope you're having a good time. Okay, by the way, I would like to get your ZSH configuration. I like the look of your terminal. So, I mean, this is the typical... Oh, the theme. Maybe you're talking about the theme? Hold on. So this is Qt, or QTerminal, and I think that the theme I'm using is called... Let's see if I can pull it out. Preferences. So preferences, the color scheme is called green on black. So green on black, it's kind of like a retro kind of color scheme. So the original file was compressed using deflate and then encoded into base64. So this is how you do it in Linux. So method 1 using CyberChef, easiest GUI. So let's see, if your Linux system has a web browser, yeah, I mean CyberChef is probably the easiest way to do this. Let's pull it up. So CyberChef is a very, very convenient tool for doing all sorts of operations on data. And in this case, we'll take the input from a file. So open file as input. I guess we could also just give it the this thing right here. So these are our base64 encoded bytes. And we'll put this in CyberChef. Are you going to be live again after this session? So this is Wednesday. We're going to be live again on Friday. So Wednesday and Friday are our normal streaming times. We also do streams on Sunday and Tuesday, but those are late night stuff, and those are less formal. Okay, so this we apply from base64, and we get a bunch of bytes. So we're being told that these are compressed, so we need to do another operation that decompresses this. Okay, paste the base64 string into the input box. From base64, drag raw deflate. Raw deflate. Okay, let's give that a try. Raw deflate. I mean, these are still a bunch of hex bytes, and I guess that it would be a bunch of hex bytes. I mean, we can save this. Save to output file. Download dot. I don't know. We'll call it download.exe. And see if this works, or if we need to adjust it more. And then we'll move the download file over here. So what kind of file is download.exe? A data file. Okay, sure. I guess we'll look at this inside of dlspy or ilspy. So we'll turn this back into base64 data, and then we'll move it over to the attack box. cat download base64 encode. And then copy all this and then move it over to the attack box. We actually don't have very much time to do this, but maybe what I should be doing is I should be doing my documentation right now, because we're going to have to come back to this again. Okay, so let's see. In our clipboard, we'll paste in our base64 stuff. Why did that not copy? Copy selection. Here, paste. Okay. Thank you very much for following on Twitch, Sebi2620. Thank you. Where's my terminal? Here it is. Okay, so here we will echo this out, pipe it into base64 decode, and then call it binary.exe. Something tells me that there's something wrong with the payload, because I see this giant gap. Let's make this a little bit smaller. Actually, you know what? I think the easier way to do this... Oh, why is my terminal so unresponsive? So we'll just get the error out of this. Oh. Actually, let's go and edit this. So we'll call it base64.txt. We'll paste in our payload. We need to make sure that there's nothing wrong here. It looks okay. Okay, we'll save it out. So this is data. Did it come out okay? Let me base64 decode again. Thank you very much, H1404, for following on Twitch. Thank you. Okay, so we'll try opening this up with DLSpy. So this was just the first part. This was just the first part, and it was already so complicated. What directory is that in? So that's in challenge attachments. Okay. So now we've got our binary executable we can look at. This file does not contain a managed assembly. Is this still not data that we're supposed to be inspecting? So because it says that this this thing cannot be loaded. So this is, I guess it's supposed to be a Windows binary. The other thing I think we can pay attention to the the file header. Oh, no. It's not. The thing that I was actually supposed to be paying attention to was download.exe. So we'll take a look at the hexes. I wonder what kind of file header this is. So usually you can tell what kind of file a file is supposed to be from the first few bytes. What is the PowerShell command doing? What is the PowerShell command doing? Actually, let's rename this to PowerShell cmd.txt. So I assume it's creating some sort of malicious binary. That's my intuition. Okay, let me ask a question. So the question is, the resulting binary has these magic bytes. What type of file is this? It's using reflection. Okay, if your output begins with the hex bytes this thing, the binary data is still compressed. Still compressed. Really? You have successfully decoded the data from base64 but has not been decompressed. Those specific bytes are not standard magic byte files for a final file type like .exe or txt. Instead, they represent a raw data block header fragment left over from an incomplete deflation routine or an unexpected encoding shift. How did this happen? It strips away the outer headers. To force a raw inflation directly from your Linux machine and drop any remaining wrap data, use the zlib inside of Python with a fallback strategy. Try these two versions. So, I mean, we're also... So this is output from the CyberChef tool, specifically from base64, and what was it, raw deflate? Raw deflate with dynamic Huffman coding. Dynamic Huffman coding. It was just one to make sure. Looks like there's no response available for this search. Thank you for not giving me the answer. Okay, if CyberChef outputted the exact magic bytes after running your recipe, it means the payload inside of the WMI repository was stored in a double-wrapped or slightly different format than the standard raw deflate. You're looking at WMI serialized headers, not the final .NET binary headers. Okay, when I did the deflate correctly, the magic bytes I got were MZ. Oh, does that mean that I'm not decoding this thing correctly? Here's why that happened and how to cleanly extract the real exe using CyberChef. So why CyberChef outputted this? To fix it in CyberChef, keep your current recipe Add a find/replace strings block. Look at the output panel in CyberChef. Scroll down until you see the distinct MZ signature, which marks the true beginning of the Windows executable. Use the find bytes or subset tool. Strip or slice everything before the characters MZ. Well, I mean, I guess I'll try continuing to use CyberChef. We can try using Python later, and by later I mean when we actually get to do this again, which might not be for a while. Okay, so what was that operation they wanted us to do? It was like find bytes. There's no find bytes here. Subset. Maybe it's just called find? Find and replace? So find by regex. So we're looking for MX, right? Strip or slice everything before the characters MZ. Wait, is it in here? I don't see it. Is the correct compression type set? So the compression type is... Yeah, that's a good question. What about the compression type? What about the compression type for raw deflate? What type should it be? Okay, the standard compression type for raw deflate is dynamic Huffman code. Okay, so it should be the raw, what was it? Huffman? Dynamic Huffman coding. So fixed Huffman coding, dynamic Huffman coding, or none. Okay, modify your CyberChef operating to slice past the footprint. Keep your base64, keep your raw inflate. Look for your output. So if the first 4 bytes are this, drag a drop bytes operation to the bottom of the recipe list. Drop bytes. Set length to 4, or whatever offset pushes the data to start immediately with 4D5A. Your output window should instantly shift to show MZ as the first 2 bytes. So drop a bytes operation. I've never used this thing. Drop bytes. I see it. Okay, so we'll drag out the find and replace. We'll drag in the drop bytes. And what do they want us to do? Set the length to whatever offset pushes the data to start immediately with 4D5A. I don't see anything that applies this properly. So start 0, length Are you removing non-alphabetic characters with base64? Are you removing non-alphabetic characters with the base64? I mean, we've got the recipe we're using is here. We've got the raw base64 string, and then we decode it from base64, and then we do the raw deflate. I'm gonna have to come back to this because we need to do our HackerFrogs. No. We have to do our demonstration now. So let me go ahead and get that started. We'll put 60 minutes on the clock, and we'll move on to the next topic. Topic 1 is done. Topic 2 is here, and topic 3 is on deck. Okay, so we're going to be doing some demonstrations. Let me get the documents. Walkthroughs for TryHackMe. Hacker Holidays 2026. And this is for day number 9. We're going to be doing day number 9 and day number 10 today. Okay, so this is day number 9, Crypto Cabana. Let's pull that up. So this is the... I think this is the easier challenge. This is... well, it's definitely an easier challenge than the stuff that we were doing previously. Okay. Alright, let's go ahead and get started. Alright everybody, this is a guided walkthrough for the Crypto Cabana Challenge, otherwise known as day number 9 from the Hacker Holidays 2026 event over at TryHackMe.com. So let's go ahead and, well, we'll first reset our progress, and then we'll take a look at what we're supposed to do in this room. Oh, this is Azure. Okay, I remember this. So we're just going to scroll down, and then we're going to take a look at the actual challenge description. So this is a cloud category challenge that is medium level difficulty, and the name of the challenge is called Crypto Cabana. Let's take a look at the concierge briefing. By the time he made it back from the breakfast buffet, his wallet had already moved on without him. The transaction was signed, properly signed, just not by him. He backed his seed phrase up weeks ago into the Crypto Cabana kiosk vault. The one whose landing page promised, in exactly 4 words, backed up, sleep easy. Somewhere between that promise and this morning, something else has gotten a good look at what was supposed to stay behind glass. Your objective: find out what the kiosk is quietly trusting to reach into the storage on its own, and see how much further that trust actually extends. So we've got an application that we're supposed to be looking at over here, and they've got the domain or the link over here. So we can copy this, and then we can put it in our web browser. Okay, and then we see this app. It says back up your seed phrase, Cabana side. So what the app is supposed to be doing is it's supposed to be backing up your seed phrase by putting in the seed phrase. I don't know if that's actually the safest way to do it, but let's go back and talk about what this is. So today's itinerary is to pull apart what the kiosk hands out for free before you've clicked anything. Follow the trust somewhere on the kiosk's own page never once points you. Somewhere in there is a second, more valuable set of keys, and a vault that won't give up the real values on the first ask. Okay, so let's talk about what's going on in the application here. So this is Hacker Holidays 2026 Day 9 Crypto Cabana. In this challenge for Hacker Holidays, we're asked to exploit a web application's associated Azure cloud integration. So Azure is a cloud service where you can put your information and integrate it into your web apps. and we're going to be taking advantage of insecurely coded applications that integrate Azure. So when we arrive on the target web page, we see that there are Azure Cloud credentials in a script that the app is using. So we'll take a look at this in just a second. Actually, let's do that now. So over here, we can take a look at the page source. And then we see that the page source references a script. And the script is this one over here, app.js. So we can take a look at this. And this script actually exposes credentials for the Azure Cloud integration. So we got the storage account, which is Crypto.Cabana. We have the backup container that is going to be saved to, called backups. And then we've got the SAS. We'll talk about what an SAS is in just a second, but this is essentially what gives access to the Azure Cloud account. So let's talk about what kind of secrets we've exposed. So the app uses an Azure SAS, that is a shared access signature token, to gain access to Azure containers, which is file storage. So if we enumerate the components of the SAS token, we can see that it is over-permissive as illustrated above. So it's got the value SP, which is stored permissions, equal to R and L, read and list. So with this token, you're able to read and list the things in the storage. So this other value over here, SRT, is our allowed resource types. So what kind of resources are we able to access using this token? In this case, it's SCO, which stands for Service Container and Object. So the SRT value in particular lets us know that we can use this token to enumerate all of the containers associated with this account. And then we can then list out all the containers associated with this account using the Azure CLI tool. So we're going to be using the Azure CLI tool a lot to complete this challenge. Let's take a look at my notes over here. So what we're going to do first is we're going to take our captured credentials over here, and we're going to do an enumeration of the cloud account. So using the methods below, we're going to discover that there are 3 containers called Web, Backup, and Vault, and we're going to do this with the Azure CLI. Okay, so Azure Storage Container List. Let me just copy this entire command. Okay, and we'll go back to our... This is for day 9. And we're going to run this command. So what are we doing? So we're running the AZ storage container list command over here. Thank you very much, Ruben7698. Thank you for following on Twitch. So we run the command, we specify the account name, which is Crypto.Cabana, and the SAS token that we captured over here. So what this will output is a bunch of information about these containers, but we're only interested in the names of the containers. So we're going to grep out on the name of the containers. And in this case, it lets us know that there's web, there's backups, and there's vault. So now that we know the names of the containers, we can actually take a look at what's inside the containers themselves. So knowing the names of the containers, we can enumerate all the blobs that are the files within each of the containers, and we discover a file that we want to look at. So we use AZ storage blob list, this command here. We specify the account name and the SAS token. We're gonna put these in some environment variables, and then we're going to output the names of the blobs, and eventually we'll get this list. Let's go ahead and demonstrate it. So back over here, we're going to run these 2 commands first. So this is going to specify an environment variable, storage account equals Crypto.Cabana, and then the second one is going to be for the SAS token. So the SAS token we're going to save to this environment variable called SAS token. So the last thing we do is we're going to run this command that is going to grab the blob list from a specific storage container. So for example, we're going to take a look at the container name equals vault, and we're going to see all of the files inside the vault container. So the SAS token, we define it over here. We're going to look for the names of these blobs, and we're going to output in TSV format. And we find two different files. So there's one called seedphrase.txt, and there's another one that we're more interested in called backupserviceaccount.json, because this might have credentials inside that we want to take a look at. So the next step is to download this file. So we download it and read it, and it contains another set of Azure credentials. So we find more credentials inside this file after we download it. Let's download it now. So downloading the blob from the container, we have to use another. Sorry, we use the same service. We use another service later. Okay, so let me grab this entire command. So AZ storage blob download. So this is just going to download a blob from a container. So container name vault. The name of the file that we want to download is backupserviceaccount.json. We supply credentials like the storage account and the SAS token. After we run this command, we'll see that we have backupserviceaccount.json in our directory. So we can read it. And we'll pipe this into JQ because this is a JSON object. And we see that we've got information that we can use to enumerate another service. So this service is called the Key Vault, and we're going to use these credentials to do so. Okay, using these credentials, we can enumerate the secrets in the Key Vault. So we're going to see that there are a bunch of secrets in the Key Vault here, and we want to read these. But first, let's go ahead and access the captured credentials to enumerate the Key Vault. So we're going to run two commands over here. So there's going to be AZ login. So AZ login service principal user is this value over here, and we provide a passphrase and then a specific tenant. So these are all values that we got from the JSON file. So after we log in using AZ login, we can then access the Key Vault using this command. So it's going to be this one here. So AZ Key Vault secret list vault name C cabana something something, and we're going to look for the names of these secrets by grepping them out. Okay, and we see that there are 4 secrets in here. So key shard 1, key shard 2, key shard 3, and the master key. So spoiler alert, we don't have access to the master key, but the other secrets we do have access to, and we can read them. Okay, so using these credentials, we enumerate the secrets in the Key Vault, and then we can read them. They contain the flag for the challenge, the stuff that we're supposed to be enumerating here, but there's a problem. So the second part of the flag has been rotated, but it implies that the redacted secret still exists. So there can be different versions of the secrets, and if you know to look for it, you could look for previous versions. But first of all, let's take a look at the secrets themselves. Okay, so we're going to use these commands here So AZ key vault secret show vault name, this vault name key shard 1 grep value. So we're just going to get the value of key shard 1, and the value is this right here, THM not your something something. What we're supposed to do is we're supposed to take the 3 parts of the key shard and then put them together. So we can do the same thing for number 2. But the value here says that rotated this after IT flagged it, old value should be recoverable if you know where to look. So this implies that we have to look at a previous version of the secret, and secret number 3 is key shard number 3, which is this, THM not your coin something something. So we need to piece this together. So this is part 1, this is part 3, and we need to get the previous version of the secret for the second part. Okay, so we can retrieve all versions of that secret and then read an earlier version of the secret to complete the challenge. So we're running a command called AZ key vault secret list versions. We specify the vault name and the name of the secret, key shard 2, and it tells us that these are the versions of the secret. So this hexadecimal value over here. So we assume that the one that is the latest one is the current version that we're looking at, which is redacted. So we're actually interested in this version right here. So we're going to run another command to look at that version of key shard 2 specifically. Over here. Okay, key vault secret show vault name key shard 2 version number the previous version. So if we do that, we get the previous version, which actually has the middle part of our flag. So we're just going to put this all together. Over here. Okay, and this is the flag for the challenge. So we'll just copy this. We will go back to the TryHackMe page. And then we'll scroll down to the bottom. What is the flag? Paste it in. And we're finished. Okay, so let's talk very briefly about what we did in this challenge before we finish up. Sagfault says, boom! Yeah, we boomed it. Right. So this is day 9. Day 9 wrap up. There was a web app that integrates Azure Cloud container blobs into its operation or into its function. We were able to steal the SAS token for the Azure Cloud account and enumerate all of the containers and blobs for that account because the SAS token was overly permissive. We found a file in the containers that had credentials for the Azure Key Vault, for the Azure Key Vault tool, and we used those credentials to steal secrets from the Key Vault. And that's it. Alright everybody, this was a guided walkthrough for day number 9 from the TryHackMe Hacker Holidays 2026 event, otherwise known as Crypto Cabana. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so Serpentor says, this is interesting. I created an app registration in Azure for a web app and valued the secret key since you can only see it once. Is that key still obtainable in the Azure tenant? And a good evening to you all. Hello Serpentor, nice to see you here. I mean, I'm not an expert when it comes to to Azure cloud pen testing, but I'm sure there are people in chat that probably know a bit more about Azure. If you can answer the question, please let us know. So the question is the key still obtainable in the Azure tenant? I think for AWS, they do not let you see the values of the keys after you create them. So you need to record the values of the keys, because you're not able to see them inside of the application afterwards. Okay, let's move on to the last challenge for today. So the last challenge is going to be, oh, what was it called? The Hollow Shell. So this one's a pretty fun one. it dealt with the web app vulnerability that I hadn't heard of before, but it's actually pretty fun. Okay, let me set up for this challenge. This is going to be day number 10. Okay, Serpentor says, I meant to say I vaulted it after in 1Password, not oh, okay. Thanks for taking my question. No worries. I'm happy to answer where I can. Alright everybody, this is a guided walkthrough for the Hollow Shell Challenge, otherwise known as day number 10 from the Hacker Holidays 2026 event from TryHackMe. Let's talk about what's going on in this challenge. Okay, so just keep in mind that you need to be connected to the TryHackMe network to do this challenge. So you either need to access it through the attacker machine, the attack box, or you need to download the VPN key and access it through OpenVPN. Okay, we will start the lab machine associated with this challenge, and then let's take a look at what's happening here. So this is a web app security challenge of medium difficulty, and what does it say here? So you find it on the beach, pretty ordinary, the kind of thing nobody thinks to check. Slip something inside and hold it to your ear. The Byte Lotus beachfront lets guests personalize their in-room displays by uploading a shell, a little souvenir pack of shoreline ambience. Staff publish them through the shoreline display portal, and once a shell is held to the room's ear, it plays its shore. Slip past what the portal forgets to check, and the shell answers with a shell of your own. Okay, so we're going to be given an IP address where we can access the room in just a second. But before that, let's talk about what the itinerary is. So the only thing that they tell us is find the flag. So that's not super helpful, but we'll understand more after we access the room. Okay, so we get the IP address here. Let me copy this, and then we'll access this over HTTP. And I think the reason why we don't see anything was because this is supposed to be on port 5000. So they actually don't tell us that the application is on port 5000, but if we go over to our Nmap port scan, we can Nmap this. which is going to reach out to the remote server and try to find out which services are open. So when we run the tool, we're going to find there's port 22 open on the system, and we're also going to find out that there's port 5000 open on the system. So port 5000 isn't typical, but port 5000 is commonly associated with apps that are deployed using Python. So we can see over here that the name of the server is called Gunicorn. So Gunicorn is associated with Python-powered apps, and requested resource was login. So this is why we go over to port 5000 to access the app. So over here, there's a login page, but if we take a look at the page source, we see that there are credentials over here. So the user is concierge, and the password is staynotice2024. So we're going to copy this password, and we're going to log in as the concierge user. So this is an example of sensitive data exposed in source code comments. Concierge, passphrase this. Okay, so we've got, this is actually a very dense amount of information we're supposed to understand here. So the app describes this: bring a shell ashore, found something on the beach, upload it as a shell, a .zip souvenir pack to set the ambiance on the in-room tablets. Each shell must contain a shell.json manifest listing its assets, images, and style sheets. So there's a file upload ability or a file upload function on this web page. So you're supposed to upload a zip file, and then we also see this message. So a shell may include optional automation hooks. The theme worker applies these for you shortly after the shell comes ashore, so you don't have to touch each tablet by hand. Allowed asset types, well, we don't really need to pay attention to these file types over here, but let's talk about what's going on in the application. So this is Hacker Holidays 2026 Day 10, the Hollow Shell. In this challenge from Hacker Holidays, we're asked to find the flag on a web server. When we arrive on the landing page of the web app, we see that there are default credentials in the HTTP source code comments. After we use these credentials to log into the application, we see that there's a file upload function that accepts zip files. So the minimum contents of a zip file to upload to the app is a shell.json file with the above contents. So you just need to create a JSON file with the contents name equals something. So this is the only requirement for the JSON file that we're putting inside the zip. So after uploading the zip file, we can see that the uploaded file gets its own directory in the /shells directory and a random alphanumeric string. So let's demonstrate this. So this is day 10. And we're going to make our minimum viable shell.json file. So it's just going to be a JSON object with name equal to something. It doesn't matter what. Okay, so we'll save this out, and then we'll zip this up. So zip, and we'll call this malicious.zip and include shell.json. Okay, and then afterwards, we've got a zip file. So we don't have anything in malicious in here yet, but that'll come later. We're just going to upload this to see what happens to it. So we're going to select malicious.zip. Okay, and then we're going to upload. Okay, shell something brought ashore, stored at shells something something and held to the room's ear. So we can see here that the something shell got put in this directory here, shells, and then we've got a random alphanumeric value. So the interesting thing about this is that it lets us know that there's a directory called shells, and if you do some enumeration on this particular endpoint, you're going to find that there's a very interesting vulnerability associated with that. And let's talk about what that is. Okay, so the shell's endpoint is vulnerable to a directory traversal attack. What we mean by directory traversal is that we're able to use a directory traversal payload to move to other places inside of the file system. So in this case, we go up a directory with our ... and then we go into the app.py file in the web root. So we're actually escaping from this shells directory up to the web app root and reading app.py. Normally this is not available to us, except that we've got this vulnerability that lets us get access to the web server files. So we're going to be using it to access the Python-powered index page app.py. The reason why we know that the index page is called app.py is because the server is using Gunicorn. So Gunicorn indicates that this is a Python-powered app, and those applications, their index page is not index.php or index.html. It's usually app.py. So this is why we know what to target. So this enables us to see a lot of sensitive data about the application, including the directory path for app hooks, which is not network accessible. So let's demonstrate how to look at the application code using directory traversal. So curl path as is. We're going to get our IP address. Where is it? It's this one. Okay. So curl path as is, HTTP, this IP address, port 5000, shells, and then we escape from the shells directory with our path traversal. So ... to go up a level. So we're actually in the web root, and we're accessing app.py. So this kind of path traversal attack isn't really available if we're using regular web browsers, because regular web browsers don't accept path traversal payloads. They normalize them first, or they interpret them first. So when we run this, we get the entire application code as a Python file over here. So the important thing that we need to pay attention to is that there's something called the hooks directory that they referenced earlier. So base directory hooks, and this is a non-web accessible directory. So this exists on the web server, but not in the web application itself. What we want to do is we want to put a malicious script in there, because the challenge indicates that there are automation hooks. And what we need to infer is that if we put something in the hooks directory, then that code will be executed. Am I missing a current topic overlay? Oh, we are missing a current topic overlay. Sorry about that. So this is topic number 2. Thanks for letting me know. Okay, so the main vulnerability for this challenge is called zip slip, which allows files to be written to an arbitrary location on the web server. So number 1, app allows insecure upload of zip files and unzips them. So we know that the application is unzipping these files. If we apply a malicious zip file that specifies an arbitrary directory on the file system to unzip the files to, then we could potentially get a malicious script to upload and be executed. Mr. Ferguson, nice to see you here. What are we working on? So I'm doing a demonstration of a challenge from TryHackMe Hacker Holidays, which is an event that happened earlier this month. So we're provided strong indication that hook files are executed by the app, so our goal is to put a script file into the hooks directory with the zip slip vulnerability. So a shell may include optional automation hooks. The theme worker applies these for you shortly after the shell comes ashore. So what we're going to do is we're going to create a zip file that includes a directory traversal payload that specifies that the included Python script file will be unzipped into the hooks directory. So we're just going to specify that when you unzip this shell.python file, we're going to put it into the hooks directory, which is two directories up from the current directory. Okay, so we put a reverse shell payload into the shell.py file, and after it uploads, it executes, which allows us to access the web server file system and read the flag for this challenge. So this is getting a bit ahead of ourselves. So the first thing we're going to do is we're going to create the malicious zip file using Python. And the Python code for this challenge was provided by Chatter's SysOS Master as well as Epistemic Anarchist. And it's this Python file over here. Let me write the file. And we'll talk about what the script is doing. So this is a Python script. We import the zip file function here, and we need to specify an IP address because what's inside of the Python file that we're going to be uploading is a reverse shell payload that gives us access. So our IP address is this one right here. So we're going to copy it and we're going to put it into our script. Okay, and then we've got a PyShell variable with a Python script in here. So import socket subprocess OS, and what this essentially does is it creates a reverse shell connection using the binsh shell in interactive mode. Okay, so this is the Python shell that we're going to, well, this is the reverse shell, but we also have this. So we're going to create a malicious.zip file. We're going to write some strings to the file. So shell.json, which is required, it's just going to have name exploit inside of the JSON file. So for the shell.py file that was going to have our reverse shell payload, we're going to put it in the two directories up and then in the hooks directory. And we're going to put as the contents PyShell, which is defined over here. Okay, we're going to print out a little message, and then we're finished. So we're going to save out this file, and we're going to run the script. Okay, created archive with files, shells.json, then .. hooks shell.py. So this is now the contents of our malicious.zip file. So in order to finish the challenge, we also need to create a reverse shell handler that is going to listen for our reverse shell connection, which we're going to do over here. So these days, it's preferred to use the Penelope shell handler for your reverse shell connections. So Penelope, I'm pretty sure it's installed by default on Kali Linux systems if you're using Kali Linux. So we're listening on port 443 for reverse shell connections. So we're going to go back to the application. We're going to browse malicious.zip, and then we're going to upload it. So when we upload it, we're going to see that the payload didn't run. Hold on. Oh, no, okay. It just took a while to actually execute. Okay, uploading shell to PTY, okay. So we've got an upgraded shell here. So the last thing we need to do is we need to enter our user's home directory, so room service, enter their home directory, and then we see the flag.txt file here. Okay, so cat flag.txt, zip slipped into a shell. We'll copy it, and then we will go back to the TryHackMe challenge and submit the flag. Okay, what is the flag? Okay. and we finished the challenge. So before we finish the challenge, we'll talk about what kind of vulnerabilities we found on the system, and then we'll wrap up. Segfault says, automatic shell upgrade is pretty nice. Yeah, Penelope is... It is the standard for like reverse shell handlers, because well, it is very, very convenient. Okay, so we're gonna do the day 10 wrap up. So on this challenge, there's a web app with leaked credentials in the HTTP source code. So the second thing we find is there's a zip upload function after logging in. And this app is vulnerable to the zip slip vulnerability, or to the zip slip exploit. So we use zip slip to place an executable script in a directory we're told executes scripts. And with that, we're able to get a reverse shell connection. And then read the flag. And that's it. Alright everybody, this was a guided walkthrough for day number 10, otherwise known as the Hollow Shell, from the TryHackMe Hacker Holidays 2026 event. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so, Axokasha says, what is the difference between the Django framework and the Gunicorn server? So they're run on different frameworks. So you're talking about, was it Django? Django and, oh wait, Django is Python too, right? It's a Python framework. I mean, I'm not super familiar with these different frameworks. So there's Django, and then there's Gunicorn, which is another Python framework. I mean, there are different frameworks for JavaScript as well. So JavaScript, there is was it Node.js? That's one framework. Whoops. And then the other one is AngularJS, I think it's called. I'm not really familiar with the differences between these frameworks, but I know that they're different ones. Please leave your GitHub link. Yeah, it's over here. Okay, how much time do we have? We've got like 17 minutes. And we're going to be doing our HackerFrogs AfterSchool. Well, I mean, we might start our HackerFrogs AfterSchool topic early. What time is it? Okay. So the next topic is HackerFrogs AfterSchool. So this is our beginner-friendly topic. Because the stuff up until now, maybe not so beginner-friendly if you're not really familiar with tech topics. All right, so I think I'm gonna take a little break because well, I've been sitting around and and I need to take a little break for about a couple minutes. But while the break goes on, we'll put on some birds and we'll be back in just about 2 minutes or so. In the meantime, you can check out this woodpecker. Okay, see you in 2 minutes, everybody. Oh, sorry everybody. I forgot to mute my headset. I guess you heard some extra noise. Sorry about that. All right, let's put the birds away and get back to what we're going to do. So we're going to start a new topic, and this should go for about 60 minutes. And this is interesting noises. Well, I mean, they're probably just me putting on my headset and like opening and closing the door. Hopefully, that was it. Anyways, let's talk about what we're going to be doing today. So HackerFrogs AfterSchool. So Linux Basics with PicoCTF, Part 3. So if you don't have an account over at Scilab Academy, I highly recommend you make one over there. Because we're going to be using challenges from this website to learn more about Linux. Not this stuff. And not this stuff. We heard the shouting and the inventive curse words. Yeah, usually that's what I do when I mute my microphone. I just, start cursing. So you heard it too. Yeah, of course. All right. So Linux operations, let me get my session notes for this one. And Nullsec, hey man, what is up? Haven't seen you for a couple streams. Hope you're having a good time. Sorry, this is session number 3. Okay, we've got a few different challenges we're going to be doing here. What's a netcat, plumbing, bases, repetitions. Okay, let's talk about this. Been lurking, studying hard. Awesome. That's what I like to hear. Okay, hey there, Hacker Frogs. This is the 3rd Intro to Linux OS Operations workshop. In the previous workshop, we learned about the following Linux commands. So we're going to be building on these. So the find command. The find command is used to search for files in the system. It can be used with many different arguments and flags to refine the search parameters. So find is a pretty common command we use on the command line to look for stuff. We use the grep command. The grep command searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. Grep is very commonly used when we're working on the command line to look for specific patterns. The makedir command is used to create new directories in the current directory. The syntax for the command is as follows. Make directory space new directory name. So for example, make directory first find. This is also very commonly used because we like to create directories to put our files in when we solve CTF challenges to keep our file system nice and organized. The rm command is used to delete files or directories, but deleting directories requires the use of the -r flag. So it typically is going to be rm space and then the name of the file that you want to delete. If it's a directory, you need to add the -r flag over here to do that. Let's continue where we left off. Let's solve the What's a Netcat challenge over at PicoCTF. So the links are wrong because it's Scilab now, but we can look it up. Netcat. What's a netcat? So this one over here. Here is the link. And let's see what the challenge description says. It doesn't say anything. I guess we need to launch the instance. So for each one of these challenges, we need to launch the infrastructure associated with the challenge. Click on the orange launch instant button. It might be a different color depending on what color scheme you're using. So the description says using netcat or NC is going to be pretty important. Can you connect to Fickle Tempest PicoCTF net at port this one to get the flag? So we're given some information over here. And you know what? Because we're working on Scilab, we can open this up in the workspace. So click on Open in Workspace, and it's going to open up a CLI terminal that you can work inside. So the CLI terminal is a place where you can practice your Linux commands. So in the terminal, we want to make this full screen because, well, it'll be a lot easier to look at if we're not looking at it all cramped. So you can right-click into the terminal, select this frame, and then select Open Frame in New Tab. So that'll open the web shell in its own browser tab, which is what we like. And hopefully it loads up soon. So if you ever find that stuff gets stuck and it's not really going, you can always reload it and try again. So I will close this out. I'll try it again. Open Frame in New Tab. It looks like the web shell is really having some troubles. Let me know if you're able to open up the web shell in its own browser tab, if you're doing this challenge along with us. So let me try reloading the whole page again. Exit the workspace, reopen it. Okay, and then open Frame in New Tab. Okay, it works. Awesome. All right, so what we're going to do, El Mexicant. Hey, what's up? What's up with you? Hope you're having a good day. Okay, so we're just going to nano and create a little document. We'll just call it like test.txt because we're just going to put some stuff in here. So inside of nano, this is a text editor. You can make your text bigger with Control-Shift+ or smaller with Control-Shift- to get your perfect Goldilocks zone. So we'll just take a look at what information we were given by the challenge. Just going to start a CTF. Awesome, awesome. Good luck with your CTF. So we're given some information that we're supposed to use. So we're supposed to use a program called netcat. Also, the command is nc for netcat. We're also given a server. So the server is fickletempest.picoctf.net. So this is the remote server that we're supposed to connect to. And the other thing we're given is the port number. So if we've got all three of these pieces of information, so the port number, the server we're supposed to connect to, and our command netcat, we can create a command that we're going to be using to access this challenge. I think I talk about it over here in more detail. The netcat command. So netcat is a versatile computer networking program, and one common use of netcat, at least with picoctf challenges, is to connect to a non-standard service on a remote server. So the syntax for using netcat to connect to a remote server on a specific port is as follows. So netcat, IP address or domain, and then port number. So for example, netcat space jupiter.challenges.picoctf.org on this port number. Okay, so let's go ahead and do that. So the challenge gives you the information here. Where was it? This one. Gonna exit the workspace in this one. So can you connect to the server? So you combine the server and the port number here. So in this case, it's this one and this one. I'm gonna copy that. We can go to our web shell. And then we're going to paste in this information. So we just need to get rid of some of the information like this so that we only have the remote server name and the port number. So in front of this, we're going to put nc for netcat. And when we run this command, we're going to contact this server on this networking port. And netcat is going to let us know what the response is. And we see here, it says you're on your way to becoming the netcat master. So we have a flag, picoctf netcat mastery, and then a custom hexadecimal value. So your hexadecimal value and my hexadecimal value are going to be different. So you can't use my flag to submit to complete the challenge. You have to use your own flag. So we're just going to copy this. We're going to go back to the picoctf challenge here, and we're scroll down to the bottom. So at the bottom, there's a flag submission field. Paste in your flag, click on submit, and then you're finished. So if you're on your web shell and you don't know what to do here, you can just press enter, and it should give you back your CLI terminal. So the other thing we should understand, oh, this doesn't exist anymore. Okay, Almexcan said that's actually really inventive for those just looking for flags. Yeah, you're talking about the random value over here. So every user has a random value that is incorporated into the flag, so that you can't share flags easily, and you can't just copy flags. You have to quote unquote do the challenge yourself to get the flag. Okay, so we're finished. If you have any questions about netcat, is usually it's a pretty commonly used program, and most of the time you're just given a server to connect to and a port number, and then you just combine that with the netcat command, and it should work. Okay, the next challenge we're going to be doing is the picoctf plumbing challenge. So let's learn about command piping with the picoctf plumbing challenge, and it's going to be over here. Let me get the challenge. Plumbing. Here you go. Here's the link. Okay, so it says here, sometimes you need to handle process data outside of a file. Can you find a way to keep the output from this program? Keep the output from this program and search for the flag. So we need to launch the challenge instance with the button over here. So let's do that. Okay, and it says connect to fickletempest.picoctf.net on port something something. So just copy the values, because we're going to be using netcat again. So we used netcat in the previous challenge. We also use it in this challenge. We're going to go back to our web shell, and we're going to paste in this information. So the only thing we need to do with this information is put netcat in front of it. And then we can run the netcat command and see what the server gives us as a response. All right, so we get a bunch of nonsense over here. So I don't think this is the flag, not a flag. So what we want to do is we want to look for a specific pattern inside of this output here. So if you hit enter, that gets you back to your terminal. So what we want to do is we want to run the netcat command, but we also want to do what is called command piping, so that we can look for specific patterns. For example, we can use the pipe character and then run the grep command, and we can look for the pattern flag, and it'll get every line of output that includes the word flag. Let's talk a little bit more about this before we solve the challenge. So command piping. So in Linux, command piping is the process of passing the output of one command into the input of a second command. So for example, here we're using netcat, and whatever comes out of netcat, we're going to pipe into the grep command. So this is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. So the way we use the pipe is like this. So number one is the first command. So run one command. The second part is the pipe. Insert the pipe character. The pipe character is usually going to be the shifted version of the / character on your keyboard. And the third part is the second command. So in this case, it's going to be grep. So whatever comes out of the netcat command is going to be put into the input as the grep command. Okay, so this runs the netcat command, and the output of the command is passed to the grep command, which searches for the output for the pico string. Okay, so why are we grepping for the word pico? Let's talk very briefly about this. Why do we grep for pico? So we look for specific patterns because this is picoctf. Picoctf has standard flag patterns. So in picoctf, a flag pattern always looks like this. So it's going to be picoctf, and then between some curly brackets, some flag value. So we can actually look for this pattern. So we can look for the word picoctf, or maybe even picoctf and then the open bracket, because we know that every flag is going to start with this. So everything after the open bracket is going to be, well, we don't know what it's going to be, but we can look for this. Let's go ahead and do that. So in our web shell, we're going to run netcat to this server on this port. We're going to pipe it into grep, and we're going to look for picoctf. And we find it. We find the exact flag. So picoctf digital plumber, and we can copy this flag. Okay, copy it, go back to the challenge, scroll down to the end, paste in the flag, submit, and then you're finished. So piping is a very useful thing in Linux. Let me demonstrate. So I've got my terminal over here, and maybe I'm going to read the etc password file. So the etc password file on Linux typically has the names of all the user accounts. So most of these user accounts aren't real users. These are accounts that are being used by software. So the software uses these accounts in order to interact with the system. For example, there's the IRC user, which is used by the IRC program. The MySQL user, which is used by the MySQL program, and etc., etc. So what we can do here is we can look for users that have a login. So you can see a lot of these users actually don't have a login. It's specified right here. So user has been no login. So what we can do is we can read the password file, and then we can grep inverse for no login. And this will get us lines that do not have the line no login on them. So these theoretically are accounts that have a login. So we've got these accounts over here that all have logins. So for example, the ShyHat, which is my user, has a login with this shell over here, user bin ZSH. A bunch of these other users have like a bin bash shell. Oh, bin false also means no login. Okay. So the interesting thing is that with pipes, you can chain the pipes together. So if you grep for no login, and then you find that there's another pattern you don't want to see, for example, false, you can pipe again and then provide another command. So grep v false, and these are the users with an actual login. So root has ZSH, sync has bin sync, Postgres has bin bash, etc., etc. Okay. If you have any questions about piping, let me know, and I'll try to answer the question as best I can. All right, so the next challenge, what is that going to be? The bases challenge. So let's learn about base64 encoding with picoctf plumbing. Oh, it's not plumbing, it's I think it was called based. Hold on, let me look up what challenge we're supposed to be doing. Plumbing bases. Okay. All right, so we're going to be introduced to a pretty common encoding system that that's used all over the place in InfoSec and cybersecurity. Useful grep command. Grep is very useful. Okay, so this challenge it's pretty simple. So the bases challenge, it says, what does this mean? I think it has something to do with bases. So we're dealing with some encoded information here. Let me point this out. So this is not a human readable string, but it's got some characteristics. So it's got lowercase letters, it's got uppercase letters, it's got numbers. And this by itself, you might be able to guess. You might be able to guess what kind of encoding is being used. Frackery, hello, nice to see you here. The other thing that is a hint about this challenge is the number of characters it has. So the number of characters here, that's 4, 8, 12, 16, 20. So this is 20 characters. So 20 characters is divisible by 4. And if you see a string that is uppercase letters, lowercase letters, numbers, and the number of characters is a number that is divisible by 4, then this is a pretty strong indication that this is a base 64 encoded string. We'll talk about what the system is in just a sec. ROT? Not in this case. So the base 64 command. So the base 64 command is a standard command in Linux, and it encodes and decodes data according to the base 64 codec. I've been informed that it's not a codec, it's an encoding system. It is often used to convert data for transmission across computer networks. So you can see there are 64 characters that are associated with base 64 over here in this diagram. I haven't played with crypto in so long. Yeah, cryptography is it's a very fun topic, but sometimes it can be a bit frustrating. So the characters used in base 64 encoding are shown here. Note that all base 64 encoded strings must consist of a number of characters that is divisible by 4. In cases where an encoded string is not divisible by 4, the encoding process will pad out the string with equal symbols until the string is divisible by 4. So for example, if we were to echo out the word password and then base 64 encode it, we would get this pattern right here, which is a base 64 encoded string. But because the string doesn't have a number of characters equal to that is divisible by 4, they have to put in this equal sign over here to make it divisible by 4. 3D Code Warrior, hello, nice to see ya. Okay, so when we solve this challenge, we need to do this. We need to run echo. We need to output the string we want to decode. We need to pipe it. And then we need to run base 64 in decode mode, like this. Okay, and I guess now it's a good time as any to talk about the echo command. So what does the echo command do? So the echo command is used to create output equal to whatever is supplied to it. It can be used to supply input to another command through command piping. So for example, we can do that over here. echo out something. HackerFrogs, like and subscribe. Okay, if we just run echo, it's going to output the message, and that's it. Cyberlock says, are industrial control systems vulnerable to attackers? And is there a challenge in addressing this issue? Industrial control systems are ridiculously vulnerable to attackers. So if attackers are able to get access to the network, it's very hard to secure those systems, from what I've been told. The only way you can secure those industrial control systems is to make sure that bad people don't have access to the networks in the first place. Okay, so we echo out HackerFrogs like and subscribe, and we can also pipe this out to something else. So often echo is used as the first part, as part of a pipe that runs another command. For example, base64, which is going to encode this string into base64. So we get this pattern right here. So if we wanted to decode this, we would do the opposite. We would copy this, we would echo out this pattern, and then we would pipe it into base64 with the decode switch. So base64-D. Yeah, no worries, Cyberlock. This is just what I've been told. I don't really interact with industrial control systems. It's just that I've been told that industrial control system security is very, very difficult. Okay, so we echo out the pattern, we pipe into base64 decode, and we get the original message back. HackerFrogs like and subscribe. Awesome. Okay, so let's solve the challenge. Okay, before we do that, I guess we can talk about the echo command. So for this example, the echo command is used to supply input to the base64 command. So echo base64 encode test into base64. So the echo command can also be used to create files containing the echo content by combining it with output redirection. We'll talk about output redirection in a little bit. Let's solve the challenge first. So back here at the bases challenge, what we need to do is we need to decode this. So we'll copy this, then we'll go over to our workspace. So our web shell. In the web shell, we'll echo, and then we'll paste this in, and then we'll base64 decode. So when you're dealing with strings like this, especially if they have special characters or like numbers at the beginning of the string, we want to make sure we put it between some quotes, so some single quotes or some double quotes, so that the system doesn't get confused. So when we run echo this pattern, pipe into base64 decode, we get the flag. So learn the ropes. I'm not sure if we can directly submit this, but we'll copy it. We'll go over to the challenge. We'll paste in the flag and submit. Okay, it says incorrect flag, try again. Can anybody tell me why it doesn't accept this flag? So if you've done CTF challenges, you probably know why the system won't accept this flag. White space? I mean, it's not white space in this case. Sometimes white space will get in the way. But the reason is because of the flag wrapper. There's no flag wrapper around this. So remember we were talking about picoctf has a standard flag pattern. So this one over here, picoctf, then some flag value inside of the picoctf wrapper. So we actually need to create the wrapper here, then paste in the flag. Yeah, that's it, right? Pretzel Pete, you're correct. Should be pico something something. So we'll copy this and then we'll submit this, and it should accept it. Unless it doesn't want to accept it. Yeah, well, okay, connection trouble, try again, try again. Okay, it says correct flag, great, and we're finished. So let's talk a little bit more about this. Demo effect, of course. So the echo command can be used to create files containing the echo content by combining it with output redirection. For example, this echo test greater than output.txt. So the above command creates a file called output.txt with the text content test. So let me demonstrate this. Actually, before we demonstrate it, we'll talk about what output redirection is. So output redirection is a feature in Linux which can be used to direct the output of commands and write that output to a file. The previous echo command is an example of this. And the above command takes the output of the find command and redirects it into a file called jpeg-filelist.txt. So we run a command, and then we do greater than, and then the name of a file. So this is a useful technique that can be used to save the output of commands for later use. Okay, so let's practice over here. So we've got our web shell. And we're just going to create, well, let's delete test.txt. And we'll echo out HackerFrogs like and subscribe. Okay, inside these quotes. So whenever you're dealing with strings, you usually want to put them between quotes. And then we will redirect it into frog.txt. One input, two outputs. Okay, it's present in any POSIX compliant system, which also means Windows. Yeah, this also works on Windows. So you can do output redirection and then create a file out of this, even on Windows. But echo HackerFrogs like and subscribe greater than frog.txt. So after we run this command, we have frog.txt written to our file system. And if we read it, we get the original message. Oh, hack frogs. It's supposed to be hacker frogs. Silly me. Let's correct this. There you go. All right. So there's also so regular output redirection is going to clobber or overwrite a file, but we can also do the double greater than sign. So if we use two greater than signs instead of one, it's going to append to frog.txt instead of making it anew. So let's see. We could do like echo second line to frog.txt. We can output third line to frog.txt. And if we read frog.txt now, we see that these lines have been added to the file instead of replaced in the file. But if we just use one greater than sign, then this content is going to replace the frog.txt file. So we see here that the rest of the contents of the file have been replaced. Samerlock says, what do you think of Rockstar and the leaks that have occurred? I mean, I don't really know very much about the story, but I guess, what did the guy do? Did the guy host the leaked files on some sort of file server? Did he try to get people to pay for access to it? I think that's what the guy tried to do, right? Okay, if we do one, it will write to a file. If we do two, it will append to a file. Yeah, that's, do I explain that? No, we don't explain it over here. Okay, so let's go ahead and do the last challenge for the day, called repetitions. So let's practice the concepts we learned this session with the PicoCTF challenge called repetitions. Let me get that. Here we go. Okay. Here's the link. If there are contents in the file, we overwrite it. Yeah, that's true. Okay, so there's the link for the challenge. It's called repetitions. Can you make sense of this file? Download the file here. Okay, so this is a challenge with downloadable files, and let's go over what it takes to download these files on the terminal. So the first thing you're going to do is you're going to highlight the link. You're going to highlight the link and then right click and then select copy link. Then you're going to go over to your web shell, and in your web shell you're going to create a new directory for this because we want to make everything nice and organized. Make a directory called rep for repetitions and then enter that directory. And then afterwards we're going to download the challenge file. So wget space and then paste in the file address for the file that the link that you copied. Okay, after you've done that command, you should see encoded flag in your current directory. So remember, the wget command lets you download files as long as you supply a valid file address. Okay, so we've got a file called encoded flag in this directory. So what does it contain? Oh, can anybody identify what kind of data this is? You can also use curl. That's true. We can also use curl. wget is a little bit easier to use. There's not as much to remember when you're using wget. Yep, some base64. So the reason we know this is base64 information is because it's got numbers and letters, uppercase and lowercase, and it also has a number of characters that is divisible by 4. So we can actually tell how many characters are in here if you, well, we can do a word count on it. So word count WC, encoded flag, and it tells us that there are 349. This is actually supposed to be 348 because they count the new line character at the end as a character. Hold on. We can copy all this. Thank you very much for following on Twitch, MLS. Thank you. So echo n this thing. Uh-oh. That's unfortunate that we... Okay, cap the encoded flag and then pipe into word count. So 349. So it says 349, but it's actually supposed to be 348 because there's a new line character in there. So what we can do, the other obvious sign that this is base64 encoded information is that there are some equal signs at the end of the string. So we learned earlier that if the number of characters is not divisible by 4, it'll add these equal signs until it pads out to a number of characters that is divisible by 4. So what do? We cat the encoded flag and then we base64 decode this. Xiaolaoshu says, the guy that hacked Rockstar basically acquired the game. He got the entire game. He even made an unstable version run on the PC so he can play it on his PC. He did this to oppose the industry standards. He's got a manifesto, you say. In his manifesto, he basically had 3 rules. Thou shalt not sell digital pre-orders. Thou shalt not sell fake single-player DLC. Thou shalt preserve single-player content. He hacked Rockstar because they violated some of his rules. And as far as I know, it has gone pretty far. I mean, I'm not sure if you're able to actually affect change in the entire gaming industry by hacking a company, because the companies practice the way they do business so that they can make millions and billions of dollars. And if they don't And if they don't do these shady business practices, they're going to lose a lot of money. And companies only exist to make as much money as possible. So they will always choose the path that earns them the most money, unless there's huge pushback. Okay, Shallow Shoe says he also installed a dead hand system that automatically leaks the whole end. When law enforcement should catch him. Oh, okay. Sagfall says one guy against the machine of capitalism. That'll work for sure. Of course it'll. Of course it'll work. One person always has the dead hand, dead switch. Yeah. I mean, I think we're talking about a dead switch. Okay, so if we base64 decode this, we see that the base64 decode actually results in more base64 information. So this is what would you call this? You would call this like recursive base64 encryption, or encoding rather. So we can actually pipe this into base64 again and decode it, and we get more base64 information. Okay, so we can pipe it again into more base64, which gives us even more base64 information. Actually, before we solve this, I can actually show everybody what this looks like. So if you were to go onto your terminal and you were to echo out HackerFrogs like and subscribe, okay, and then base64 encode it, you can take this and you can base64 encode this again, which is going to be like another layer of base64 encoding. So take this, pipe it into another base64, and then you get an even longer string. And then you can base64 encode this again, which gives you an even longer string. Okay, Cyberlock says he has a copy from one of the agents in India. How do we know that the agent was from India? Did he disclose that, Cyberlock? Layered? Yeah, these are layered one on top of each other. Babushka encoding. Yeah, I guess you could call it that. Baseception. Kitty sack. Hello, nice to see you here. Can also run hex identifier. Hex identifier? I haven't heard of that tool before. He had an accent. Oh, okay. An identifiable accent. Would CyberChef decode it? Yeah, you could decode this using CyberChef as well. Let me demonstrate. So this is base64 encoded 3 times. So we'll copy this. We'll go over to our CyberChef tool. So cyberchef.io. This is a pretty common tool we use for cybersecurity. You can put in your input here, and looks like, okay. So our input is here, and we're going to base64 decode. So the operation is called from base64, and we see that there's more base64, so we apply from base64 again. And we see there's more base64, and then we apply from base64 again. And we get the original message, HackerFrogs like and subscribe. Magic is such a banger operation. I mean, yeah, we could also use the magic operation as well. Let's see if we can do that. Okay, so here, it says from base64 will produce HackerFrogs like and subscribe. So magic is one of those fun little functions we can do inside of CyberChef. And yeah, it was able to identify this. So from base64 3 times, and the resulting snippet is HackerFrogs like and subscribe. Is it base 32? It's not base 32. So we're talking about base 64, but there's also another system called base 32. So base 64 is what we're talking about right now. So it's got all of the uppercase letters, all the lowercase letters, all the numbers, and the plus and the slash. So this is the character set for base 64. But there's another system called base 32, which is only the uppercase letters, but not the lowercase letters. So it's these plus these. So if you see a string, but it only has uppercase letters, then it might be base 32 encoding instead of base 64. Okay, would hex identifier find the hash type? It's built into Linux. Hash identifier? I mean, base 64 is not a hash. I mean, we could put in a base 64 encoded thing. So echo something to base 64. No, pipe into base 64. I'm not sure if it's going to identify this or not. Yeah, it says not found. It's because this is not a hash. This is encoding. What's the time there? Nova, hello, nice to see you here. It's 4:40 p.m. where I am. Okay, so let's go ahead and complete the challenge. So over here, we're base 64 decoding over and over again. And I think it's like something in the neighborhood of like 8 permutations or like 8 repetitions. So each time we encode this, the string gets shorter and shorter, because if you base 64 encode over and over again, the string gets longer. So if you decode it, it gets shorter. And we get this flag, PicoCTF based nesting decode. I mean, there's a difference between hashing, encoding, and decoding, and I'll explain this real quick. Differences between hashing, encoding, and encryption. So what's the difference? So hashing is a one-way operation. It quote unquote can't be reversed. So hashing only goes one way. Encoding is a well-known system for transforming information or transforming data. It's meant to be easily reversed. So that's encoding. And like base 64 is encoding, not encryption. So encryption is a system for disguising data so it can only be read by the correct parties. So it's not meant to be easily reversed. And typically encryption requires a key value to be known for decryption to take place. Okay, I hope that explains the differences between hashing, encoding, and decoding. So Pretzel Pete said something about hash ID. It doesn't apply here because this is not a hash. Okay, hashing it like Ethereum wallet addresses. I mean, Ethereum wallet addresses, they look like hashes. They look like hashes, and a lot of hashes look like they mostly look like hexadecimal strings, but that's kind of getting away from what we're doing over here. Anyways, we've got our flag. We'll copy it. Then we'll go over to the challenge description. We'll scroll down to the bottom. We'll paste in the flag. Click on submit. We're finished. All right. I think that was the last challenge for the day. So let's review the Linux commands we learned in this workshop. Netcat. So Netcat is a versatile computer networking program, and one common use of Netcat, with PicoCTF challenges in particular, is to connect to non-standard services on remote servers. We talked about command piping. So command piping is the process of passing the output of one command into the input of a second command via use of the Linux pipe character. And we also learned about the base64 command. The base64 command encodes and decodes data according to the base64 format. It is often used to convert data for transmission across computer networks. So that what a lot of people don't know is that base64 was designed so that we can transmit binary data, which often has unprintable characters, across networks that might be adversely affected if those raw bytes are used. We talked about the echo command, and the echo command is used to create output equal to whatever is supplied to it. It can be used to supply input to another command through command piping. It's the core of MIME. Yeah, M-I-M-E. And we learned about output redirection. So output redirection is a feature in Linux which can be used to direct the output of commands and write that output to a file. What's next? In the next Linux OS operations workshop, we'll keep learning about Linux commands through the PicoCTF platform. So let me take a quick look at what we're going to be learning in the next workshop so that I can sneak peek it for everybody. So this is going to be session number 4. What are we learning? So we're going to be learning about different operators. So the ampersand operator, the double ampersand operator, okay, output redirection, the touch command. Okay, so a bunch of good stuff. All right, everybody, that's going to be on Friday of this week. So this is the first regular stream on Wednesday. And we usually do another one on Friday, and that's when we're going to be doing the next session for Linux OS operations. But we're going to be getting into another topic, which is going to be our challenge. Let me go ahead and switch up the overlays. There we go. Reset the clock. We'll put 2 hours on the clock because this is the last challenge of the day. Okay, so we're going to be doing this challenge over here. So it's day number 11 from TryHackMe's Hacker Holidays event. And I was in the middle of doing this challenge the last time we did these. And I was not finished, so I need to finish this. We'll talk about what we discovered on this app. And this is, well, it's a free challenge, so anybody could potentially give this a try. Just a second, I'm going to take a little bit of a water break. Okay, so Infinity Pool. So the first thing we need to do is we need to start up the challenge. So this is a boot to root challenge with a pretty heavy emphasis on local port forwarding, which is a type of network pivoting. If you've never done network pivoting before, it's a very cool process where you're able to redirect network traffic. Anyways, let's start the lab machine, and then after a minute we can start. So let us know in the chat, have you done network pivoting before? Say, type in the word pivot if you've done network pivoting. So maybe some pivot and then some smiley faces like this. There you go. Pivot. Okay, so this is the Infinity Pool challenge. It's a medium difficulty boot to root, and what are we supposed to be doing here? So find the user flag, find the root flag. Just not as much as I'd like. I mean, pivoting is pretty fun. You're able to access stuff that you're normally not able to access because of network restrictions. So I guess I can talk about it real quick. So in this challenge, we're going to be doing something called local port forwarding. So there's an example, right? So example is there's a remote server with localhost services. So for example, there's a localhost web page that can normally only be accessed from the localhost itself. So if you log into there, you see that the localhost web page is not network accessible. So what we want to do is we can connect the remote servers localhost web page to our servers localhost on a specific port, and this would enable us to see the remote servers localhost web page on our machine's web browser. So though we would do this, there's a bunch of different tools we can use for network pivoting and local port forwarding, and we'll talk about one of those tools today. Okay, we've got our IP address. We're just going to copy this, and then we're going to do our Nmap port scanning. So we see there's two ports open. There's port 22 and port 80, and we're going to access this on port 80. Okay, so it's a pretty typical website over here, except that there's one pretty common web app vulnerability on this page, and it's called robots.txt. So robots.txt is a file that you can include on your web server, and robots.txt by itself isn't a vulnerability unless you put sensitive information in here, because robots.txt is meant to tell search engine robots which parts of the website can and cannot be indexed by search engines. So in this case, they're disallowing these two endpoints, internal and status. But the thing is that if you indicate that we're not supposed to index these, if there's a bad person like us and we see this, we automatically are attracted to it. Mr. Dravo, hey, nice to see you here. What is up? How's it going? We're just doing our challenge portion of the stream. So internal and status, we want to check out these endpoints. So we'll just copy status into here, and we'll put it in, and we've got this part of the website. So it's sister property connectivity. Confirm a remote property response before routing a guest transfer. So what's going on here? So it says property host, for example, 10.0.0.5. So this is an IP address. So what they're expecting you to do is to put in an IP address. So if we're connected to the network, our IP address is this on the 10.0 interface. So we're just going to copy this. We're going to put in our IP address in here and check. So after we run this command, this looks very familiar. So this output here looks just like the Linux ping command, and we can actually confirm this. If we run ping c1 to localhost, does this work? It does work for a localhost, okay. Okay, so one packet, so 64 bytes from localhost, something, something. So this output looks just almost exactly what we see from the web app here. So this indicates that the web app is using a Linux command and outputting the Linux command to the web app, which is a pretty good indication that the app might be vulnerable to OS command injection. So OS command injection is where you're able to put in your own commands. You're able to execute your own commands through the web interface. So in this case, we can give a very typical OS command injection payload that looks like this. So let's pretend that the command, but we know that the command that's being run, it's ping c1 IP variable. So the IP variable is actually user supplied, and it's this what they're supplying right here. So what we're doing is we're going to sub out this command over here. So ping the IP address, and then stop that command, and then run the whoami command. So this lets us run our own commands in addition to whatever the application is trying to do. So we can actually run arbitrary commands from the web app. So when we run this command, we get web. So the name of the user that is running this command is called web. We can substitute whoami for any other Linux command, like ls la to see what's in the current directory. And we see we see everything in the current directory, so the directory from which this application is running. So what we want to do is we want to get direct access to the server. So what we're going to do is we're going to supply a reverse shell payload. So my favorite payload to run is the BusyBox netcat reverse shell payload. So that requires BusyBox to be on the system, and BusyBox is a Linux utility that has a bunch of other Linux commands integrated into it. So BusyBox has stuff like netstat, it's got netcat, it's got ping, and a bunch of other commands. So if we have access to this binary, we can use BusyBox to run netcat-e, which is normally not allowed on Linux systems. So netcat can be used to create reverse shell connections. The easiest way is to use netcat with the -e flag, which is not typically present on modern Linux OS distributions because it's dangerous. But BusyBox's netcat has -e. So let's show everybody what the meaning of this is. So reverse shell payload, we can craft it using using a tool like revshells.com, and we get to choose which tool we use to send the reverse shell payload. So in this case, it's BusyBox netcat -e. So this is what the BusyBox command is going to look like. So BusyBox runs netcat and connects to our attacker machine on this port. And upon connection, it executes bin bash, which gives us our reverse shell connection. So let's copy that. Let's go back to the web app. Actually, before we do that, we need to set up a reverse shell handler. We're going to do that with Penelope, which is the most popular shell handling program right now for pen testing and for CTF stuff. So Penelope is going to catch whatever reverse shells are sent from a victim machine, and it's going to upgrade those payloads. It's going to upgrade those shells to a fully functional shell. Normally, when you just use regular netcat to catch a reverse shell payload, the shell is usually not very functional. Okay, anyways, where's our web app? Here? Okay. So we'll just paste in our payload and run this. So from here, we get our reverse shell connection, and Penelope upgrades our shell. So this is just like a typical SSH shell. We've got command history. We've got file autocomplete. We can move inside of the terminal line like this. And we can also get access to terminal text editors like nano test.txt and then create something. This is me doing text editing. So typically your netcat shell is not able to do all these things. Okay, so the next thing we need to do is we need to do some privilege escalation. I think I've got a partial write-up over here. Let's take a look at that. Okay, so for our privilege escalation, what we're going to need to do is local port forwarding setup. So we need to access a few locally hosted web pages. So we're going to do some local port forwarding to allow us to view the web pages in our web browser. Okay, so let me just demonstrate what's going on here. So we're going to take a look at the listening ports on this machine. And we see that some of these ports are exposed on every interface, so 0000, but some of these ports are only exposed on localhost, which is 127.0.0. Well, would normally be 1001, 127.0.0.1, and it is over here. So port 9000 is exposed, 3306, 88, 8080, 8089. So these are not accessible to the net. What we need to do is we need to do some port forwarding to expose these to our attacker machine. So let's go ahead and try curling one of these down just to see what the contents are. So this is from the remote server. We run curl on 127.0.0.1 on port 8080. Let's put some HTTP on top of this. So this is the web page, but we don't have access to port 8080 on our attacker machine. So one method of local port forwarding. Use SSH. So this requires us to have SSH access as a particular user. Requires login credentials or SSH private key. So what we're going to do is we're going to create a private key for this user. We don't know their password. Otherwise, we'd use that. Okay, actually, we're not actually creating a private key for this user. We're adding our keys. Sorry, adding our SSH public key to their authorized keys file. Okay, so this is what we're going to do. So we have a SSH public key, which we can put into their system. So typically this would be in the SSH directory in a file called idrsa.pub. It might be slightly different, but this is the one for my attacker machine. So the ShyHat at HackerFrogs. We're going to copy the contents of this, and then we're going to go back to this user's home directory. And they have an SSH folder here. And there's an authorized keys files in here. We're going to put our public keys into the authorized keys. Okay, save it out. And now we can use our private key, so the ShyHat at HackerFrogs private key, to log into this system as the web user. Let's go ahead and do that. Well, I'll demonstrate that, and then we'll do our pivoting. So we'll call this one pivoting. Let's give it a fancy color. How about some purple? No, green. First of all, let's move into so this is day 11. Oh, there's no day 11. We need to make that directory. Whoops. Okay, and then we'll enter that directory. And then we'll log in. So SSH web at the IP address. Which IP address was it? This one. Okay, and we're going to indicate a SSH private key. It's going to be home.ssh ID RSA. It's going to ask if we want to continue connecting. The answer is yes. And now we're logged in as the web user. Okay, so now that we've got SSH access as the web user, we can set up our local port forwarding. So typically we would run a command that looks like this. So it's a pretty long command. It's got all these elements. Okay. So SSH-I and then the private key file that we're using. Then -n. I think -n means do not actually log in. And then we provide a local port forward. So local port forward 3000. So our port 3000 is going to be associated with the local hosts on the remote servers port 3000. Same thing for all these other ports. So 5038, 9000, 8080, 8083, and 8089. So after we've done this, all of these ports on the remote server are going to be connected to our local hosts port these ports. Okay. Let me copy that command. We'll run it from over here. Whoops. Actually, no, it works. No, it doesn't work. It doesn't work because the IP address is different. Okay, I need to switch out the IP address over here. Okay. So now that we're connected via local port forwarding, we should see that on our own machine, we've got a bunch of ports that are listening. So these ones over here, so the ones that we specified. So from here, we have to do some serious enumeration because there's a lot of stuff going on in this box. So let's take a look at the web page directory. So there's HTML and Infinity Pool. And inside of Infinity Pool, there are 3 applications that are being run here. So there's one called Automation, one called Edge, and one called Watchtower. If we take a look at the running processes on the system, we see here that there are processes for each one of these. So Automation, Edge, and Watchtower, they're each associated with a process that's running Python 3. And they specify which port they're running on. So port 9000, port 3000, and there's port 80 over here. So what we need to do is we need to figure out what's going on these applications. So we've already connected them to our own local host, so we can go to localhost port 9000 to take a look at one of them. Okay, so which one was this? So 9000 is the automation port. There's another one called the Watchtower that's working on port 3000. Okay, so we see here there's Watchtower internal, surveillance operations. We see here that there are 2 endpoints that are referenced here, API health and API config. So we probably want to check these out. There's nothing. Okay, so while I'm doing this, I really want to start documenting this because I've got my walkthrough partially done. Okay, enumerating the web apps. So is this your real voice? Yeah, it's my real voice. Piyush Patil. Hello, nice to see you here. Why wouldn't it be my real voice? Okay, so the web apps. There are 2 extra web apps that are referenced in the running processes. So we want pxaux, we pipe into less. These ones. And let's grab that from the server. Actually, let's get the entire thing. Let's make this extra small. And let's get whoops. Copy that. So this is the first one. The second one is this one. So we check out the app on port 9000. No, port 3000. So this is what's on port 3000. So there's reference to 2 service endpoints, API health and API config. So 2 endpoints indicated. Okay, so these ones. So we need to check these out. So we go to API config over here. And we get credentials. Okay, love from India. Your voice is so extravagant. Extravagant? Okay. I think there was another person here from India. I think their name was Nova. Nova, if you're still here, say hi. All right, so what does it say here? Automation endpoint, so it's this thing. Internal network only, do not expose. UCP still on default template creds. So there's reference to something called the UCP, and they've got template creds. Right. So this is the user and this is the password. And we have a portal that leads to UCP. Oh, 2 days of insomnia. That sounds really bad. I mean, I've been there before. I've had insomnia before. It's horrible. I hope you can get some good rest. Okay, so let's talk about the config endpoint. So the config endpoint exposes credentials as well as an endpoint for a portal. So those are going to be these. Oh, interesting. Yeah. This is where it points us towards some other ports. So in this case, it's like 8080 instead of port 9000 where we are now. So the user is free PBX template creator. Copy that. And their credentials are stay noticed 2026. With the endpoint, this thing. Scott Astatine, hello, nice to see you here. Hope you're having a good day. What are you working on? So we're working on day 11 of Hacker Holidays from TryHackMe. This is an event that happened earlier this month. And there's a bunch of different challenges across different categories of cybersecurity. The link for it's over here if you want to give it a go. It's completely, they're all free. Thank you very much for following on Twitch. Existential Noob, what a name. Glad for the follow, thank you. Okay, so that was one endpoint. So the other thing we need to pay attention to is the health endpoint, because there is config, there's also health. So health, watchtower status okay. Watchtower status okay. Bind is to port 3000. Okay. Wait. What was the other one? Config. Config was to port 9000. So we know the automation app is on port 9000. The telephony portal is on port 8080. Okay. So the two endpoints, API health and API config. The config endpoint exposes credentials. The health endpoint, what did it give us? It just tells us okay. So that's the app on port 3000. We were told there's an app on port 8080. With the endpoint UCP. So we're going to check that out. Over here. Oh, you know what we need to do? We need to make sure that our machine isn't going to expire, because there are time limits on these things. So 26 minutes, add an hour. User control panel. So UCP, user control panel. What is this? So it looks like it's trying to log us in as the admin user. Is TryHackMe your website? No, it's not my website. It's a cybersecurity education platform. I don't own it. I just use it. Okay, so this is associated with free PBX, which is a certain type of software. And typically, if we're able to identify specific versions of software, we could potentially look up vulnerabilities associated with those. So at that endpoint, we see a login page for an app called Free PBX. Conrad asked, do you have a laptop? I mean, may I ask what model? So Free PBX is the front end for Asterisk. So Asterisk is another type of software we need to interact with. Conrad asked, do you have a laptop? Yeah, I have a framework laptop. It's the most expensive purchase I've made in like 10 years. I've had the laptop for about 3 years, I think. I've had that laptop for 3 years. It's a pretty nice laptop, but I don't really make full use of it. So it's the Framework 16. So what is this thing right here? USB something something. So admin, we can try to log in because it looks like there's just credentials auto-filled here. Invalid credentials. Invalid login credentials. We're actually given some credentials, right? So these ones. Free PBX UCP template creator. And then a specific password. So we'll just plug these in. Let me just delete some of these tabs I'm not using. Okay. Log in. Okay, so we use the credentials from the API config endpoint from port 3000 to log in. Congratulations, you just successfully logged in for the first time. Would you like a tour? We do not want a tour, so we'll end the tour. Okay, so this application over here has some important stuff. Maybe in the user settings, user details, interface settings. No? Okay. So an interesting thing about this application is that it's a PBX. So PBX lets you interact with telephone stuff, and they've got one for voicemail. And we might be able to take a look at some of the voicemails in here if we add this template, or the widget rather. Drag it in. There are no active dashboard. Okay, we need to create a dashboard. Let's do that. So create dashboard. We'll call it HackerFrogs dashboard. Other plus, yeah. Okay, and then we'll add the voicemail. Okay, and the voicemail actually has some information we can we can use. So automation key cc auto something something. It also indicates like 9,000. So, and 9,000 is associated with the automation app. So let's copy this entire thing. And we'll update our write-up. So we use the credentials for this endpoint to log in. Once inside, we can see this app is used to manage telephone systems. We create a dashboard for ourselves. Then we create a voice, what was it called? Voicemail? Voicemail, yeah. Voicemail widget for this dashboard. We see that we have a voicemail, and the metadata contains this. With the number 9,000, which implies that it's to be used with the app on port 9000. Okay. So we got this info. I think that's all we need for this. So we're gonna go over to the app on port 9000. It says that the requested URL was not found on the server. So there's no landing page here. So what we could do is we could do some directory busting for port 9000. So directory busting is basically trying to find out what kind of endpoints exist on a target. So we can run our derb tool on this to see what's up. So we'll leave this running for a bit, and we'll come back to it later, because it might take a little while to enumerate. So port 9000, there might be an API interface on this as well. No, don't see anything. Or UP. The other thing we could do is we could try to find out more information about these applications on the remote server itself. Because there's like an automation endpoint over here, a watchtower endpoint, but I don't think we've got permissions to read these directories. We only have permissions to read the edge. Wow, that's a bit loud. Let me turn that down. We can't read these directories. We know that the applications are being run out of them. If we could read the source code, that would really help. But we've got access to the edge one. So the other thing we were told is about the type of application that's being run from port 8080. It's like, what was it? 8080 UPC? UCP. And it was called FreePBX. So we might try to look for some configuration files for FreePBX on the server. FreePBX Linux config file location. Okay, so in FreePBX, primary configuration files are located in the etc asterisk directory. Okay, we can check it out. Permission denied. Okay, well, I mean, even though we don't have access to the directory itself, we might be able to read files if we know exactly what the names of the files are. Key file locations, etc asterisk. So extensions.conf, sip.conf, we could try reading these directory. Nope. I mean, it exists, but we get permission. Well, actually, we don't even know if it exists, because we could do like, you know, clown.conf, and it would give us the same message. Sip.conf. Nope. There's also etc freepbx.conf. Okay. Let's give it a try. Permission denied. Does it exist? Oh, it does exist. Okay. So we do have access to the Edge app. There might be configuration information in here as well. So inside of like app.py or like wsgi.py. Nothing there. Okay. Well, Journey of Ranger. Hello, nice to see you here. Thanks for letting us tag along with you as someone who is familiar with IT and broad cybersecurity principles and concepts. Can you recommend a good starting point so that we can get caught up? It really depends on what your level, what your familiarity of tech is at your current stage. So I've got like get into cyber link over here that leads to my Reddit, and it talks about how you can get into cybersecurity from an absolute zero experience level. If you've got experience in tech, then your path might be different, but let me know what it is, what your experience is. You know what? Did we see this app.js file? Let's just take a look at it for fun. Okay. Status posts. This staff connectivity tool at status post to the legacy internal net check handler. Keep it out of the public nav until the new auth gateway ships. Oh, okay, we've seen this before. Oh, we found one called health. Okay, so we found an endpoint called health on port 9000. Let's check it out. 9,000/health. Okay, this service status authorization bearer automation key. So we got an automation key. So get health post jobs export. Ah, okay. So there are some other endpoints here. So post jobs export, authorization bearer automation key, body is report name, run as root service automation. All right, so we probably want to check out the post request to jobs export. Anyways, let's copy that first. We'll try to access this using curl. Curl localhost 9000 this endpoint, jobs export. And we'll include some data. The data is going to be our bearer token. So the bearer token is a cookie. This over here. So automation key, CC auto something something. So we'll copy this. So this is bearer token. Actually, this would be a header, right? So it's a custom header. Typically it goes in a header. Yeah, you're right. You're right. So bearer CC auto something something, export, and it has to be a post request. So because it's a post request, we have to send some data. So we're just going to send some null data and see what happens. Error missing or invalid bearer token. Hold on. Bearer token HTTP header examples. Okay, it's authorization bearer something something. Okay. Okay, field report is required. So let's figure it out. Report name. So the body has to be report name. I mean, we don't know what what report name we're looking for. So the post body is going to be for some reason I think that it's looking for some JSON. So health service status jobs export. So jobs is not available. Jobs export. Method not allowed. So we got this because we didn't send a post request. Okay, so I think what we need to do is we need to get these report names. Either get the report names, or the report name would be some sort of OS command injection payload or something, right? Yeah, thanks, SysOS Master. So this is the asterisk automation. job export, file name. So it's called the asterisk app. Skate or Die, hello, nice to see you here. And thank you very much for resubscribing on Melkip Kano. Thank you for the tier 1 sub for 2 months. Thank you. Have a lot of knowledge. I like this. Thank you. Thank you very much. Apologies for the delayed response. I'm currently a few minutes behind the live stream. Oh, no worries. I should put a timer on that next time. I forgot you started 3 hours and 44 minutes ago. But thank you very much, Melkipeno. Melkipkino. What cybersecurity are you most excited for about in the near future? I mean, I'm just going to keep on keeping on. I'm really excited about learning about binary exploitation and reverse engineering. Let's give Melkipino a redeem. How about some Jurassic Park for you? And thank you very much for the sub.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Cuckoo Kachu? Alright, let's so for people who are looking to get into cyber, check out this thread over here on the Reddit. In Asterisk, there's no singular app automation job export file format. Let's see. So if you're automating the export of call history logs, Asterisk automatically updates a local CVS file continuously. Master.csv. So maybe specify this file then? So we're talking about a report field, right? So this implies that it's JSON information. JSON information looks like this. Report master.csv. Field report is required. Hold on. So curl descend JSON. Curl send JSON data. Dash JSON flag. So curl JSON instead of D. Try header application JSON. Oh yeah, it might have to be that. Hold on. I guess in this case, it's not necessary. Hanzo League, hello, nice to see you here. Hope you're having a good day. Okay, so command tar CSV. Okay, so this tells me, so we get master.csv, right? I mean, can we just put anything in here? Just like blank? Yeah, okay, so that was the contents of master.csv. Dash JSON is new to me. I mean, curl, there's a lot of secrets to using curl. Command tar czf var automation exports. Okay, and then output tar removing leading something from member names. So do we try exporting master.csv.tgz instead? csv.tgz. Hold on, I want to make sure that I'm in the correct directory. I hope you're doing great. Yeah, just trying to figure out these CTF challenges. tgz.tgz. And wait, it keeps on going? So we add a third tgz? Something tells me that it just keeps on going. Wait. So if the application is vulnerable to like path injection, then we could access the contents of other files, right? So the report would be something like ... I don't know, etc shadow. Nope. You control the data going in that command. Well, it looks like this isn't valid. So, I mean, we can put anything in here. So report equals test. Yeah, okay, so if it's running tar czf, so tar is a pretty notorious binary in Linux for like for exploits. So for example, if you go to what is it called again? What's the name of that website? The name of the website that tells you the vulnerabilities. GTFO bins. This one. Yeah, GTFO bins. So there's going to be a lot of stuff for tar over here. So we can do stuff for shell, file read, file upload and download. But we're not really running this command. We're running, it's running a specific tar. So it's tar czf. So var automation exports. Do we have access to this directory? So var automation. Yeah, so var data and exports. And it looks like we can read these directories. So we can move into exports. Wait a minute, I'm pretty sure these are all blank. Oh, they're all the same size. So what is this thing doing? So tar czf. You know, we could probably get an explanation from another handy dandy website called Explain Shell. Explainshell.com. So write down a command line to see the help text that matches each argument. So let's go ahead and grab all this. Okay, so tar is going to do C, create a new archive. So it creates an archive. Z is filter the archive through gzip, okay, and then F. F is file equals archive. Use archive file or device archive. This option is not given. Tar will first examine the environment variable tape if it is set. So, okay. I'm going to see if we can inject into this, command to get like remote code execution. So I'll ask our friend Gemini over here. We're doing a CTF where we can specify a file name that is being fed to a tar command. Can this be used to achieve privilege escalation? I guess here is like filename.tgz. This pattern can often be leveraged for privilege escalation if the tar command is running with elevated privileges. Okay, I mean, it's running as root. I don't think this is the way, but you could try something report test curl your IP. Oh, yeah, like OS command injection, right? Yeah, so just test it for, so test, and then who am I? What was this? Cowardly refusing to create an empty archive. Oh, okay, so it takes this as another argument. Wait, maybe if we run the command with a hash? So it interprets each one of these as a different thing to be tarred. Yeah, we can also try with different terminators. In this case, we can try the terminator here. We could try to create like or. We could try the double ampersand and let's see, semicolon is your friend. Because after all this, if we look at our directory here, it looks like it didn't actually get exported. Okay, let's take a look at these. So master CSV something something compressed file. You need to do something? Yeah. Hold on. Let's just take a look at, so in your command, this, depending on the script, executes this line. An attacker can exploit it in two primary ways. Argument injection via tar flag's checkpoint. So tar has a built-in operational flag that allows executing arbitrary commands, most notably -- checkpoint and checkpoint action. So you can inject arguments via file name. You can force tar to run commands as whatever user is executing the script. So checkpoint equals 1. File name itself is passed as a command line argument to tar. You might inject checkpoint equals 1, checkpoint action equals exec sh your script.sh. Direct command injection shell meta characters. So if the script passes file names directly to the shell interpreter, you can use shell meta characters to break out of the tar command entirely and execute arbitrary commands. So setting the file name to test bin sh something something, or write a reverse shell or add an SSH key if output array direction is constrained. So what is it? Who am I? Where was it? Here. So report we tried to this is kind of weird. So this is where it's created. Oh, maybe we need to create our own file over here. The other thing we could try is we could try like command expansion. DieDev says you can use Control K to delete to the end of the line for any shell that supports readline. Control K. Report 1.tgz/root ID echo. 1 root ID echo. Oh, right. Yeah. So that's not the solution, it's a hint to get there. Right. So we can make files with weird names. You just need to so 1.tgz/root report something something who am I? Report null byte? No, that's a new line. Something new line who am I? Test new line. Okay, who am I cannot stat. Okay, let's try creating this file. Maybe we need to put this between some. I think there should be a way to insert a new line directly. Maybe leave it unquoted before pressing enter. Unquoted. Doesn't like that. Okay, let's take a look at weird file names. tar, csv, var, okay. Shell meta characters. Try setting the file name to something something. Check that in the CTF. So I think we might want to take advantage of the checkpoint maybe. So like checkpoint equals 1. So tar with checkpoint. Privilege escalation tar checkpoint. Okay, privilege escalation wildcards with tar. Let's take a look. So if the tar command is used improperly with wildcards, with higher privileges, usually used by system admins, so tar checkpoint action exec malicious file. In directories archived by tar. Okay, I don't think you can use that here because of you need the tar command to have the wildcard asterisk, right? Yeah, to run checkpoint. So in this case, we're using funny file names. Okay. Can we use unusual file names? Unusual file names to trick tar into running system commands. So kind of like what SysOS Master was talking about, there's nothing interpreting your %0a in this case. Yes, you can use unusual file names or payloads containing tar flags. Shell quoting. Let's take a look at the command structured. So the variable is unquoted, which is vulnerable. The variable is unquoted. Var automation data. So if the script executes the command like this without double quotes around the file name or variable, the shell performs word splitting on the file name. We've seen this. So if you put a space in your file name, then it interprets it as 2 file names. So if you supply spaces within your input, the shell splits your single input into multiple separate arguments passed to tar. Scenario B, the variable is quoted, secure against this specific vector. So we would, okay. So how the exploit works in the unquoted scenario, if the variable is unquoted, you can inject tar operational flags, most notably checkpoint and checkpoint action, to force tar to execute system commands as whatever privileged user, for example, root, whoever runs the script. Tattletale says, I hate Windows. Is somebody forcing you to use Windows? First, create a malicious script on the target system in a directory you have write access to, like temp. It knows my MO. So what I usually like to do is I like to create a... Why do we have to echo this, though? We can just nano these commands into a script. But I guess echo works as well. Okay, let's move into the temp directory. Well, actually, nano temp malicious.sh. Just put this in there. Okay, so Hanzo says, my bad, I think you can use checkpoint because it's passed directly into the command. Echo would work remotely as part of the payload, nano would not. I mean, we've got, in this case it works because we've got direct access with an upgraded shell. Okay, so copy bin bash into temp root bash and chmod plus s temp root bash and then chmod plus x temp payload.sh. I mean, we only need to do this to create our SUID bash binary. Okay, here doc would also work here as well. Telltale says bought a laptop with Windows pre-installed. Thanks for asking. Want to install Linux. I am not installing WSL on this one. Well, I mean, I'm not telling you to. Okay, so let's make it executable. chmod plus x temp malicious.sh. Now executable. Okay, and then we need to run that script. So triggering the injection via the file name, set your input file name variable to inject the checkpoint flags. So checkpoint equals 1, checkpoint action equals exec sh. Analyzing the resulting command line. I mean, is it that easy? I guess we'll find out. Checkpoint 1 command. Oh, never mind. This is the wrong window. Silly me. No such file or directory. I mean, it didn't work. Although it created something. So it created checkpoint 1. Wait, did I create that with my previous command? So let's get rid of this thing. Checkpoint equals 1. Oh, we can't even delete it anymore. That's funny. Wait, root created this file. Okay. You finished your CTF pretty fun? That's awesome, El Mexicant. Did you, are you up on the leaderboards? You need, like, test checkpoint. Test checkpoint. So it's the same, it's like the same thing, only we... Test. So checkpoint 1, I mean, it tried to turn all these into... No, I mean, I understood it was root, but everything that's created is root. I guess I forgot that I can't delete anything here. I'm more focused on learning and understanding the material instead of leaderboards. That's a good way to look at it. Because learning is more important than points, unless the points lead to big cash prizes, in which case the leaderboard is very important. So when the automation script runs, the unquoted shell expansion transformed the command into this. Checkpoint 1, checkpoint action exec. Okay, because of word splitting, tar parses checkpoint 1 is an active command line option. Tar parses checkpoint exec. Okay, I don't think anything happened to... Nothing actually executed, right? All we've got here is our malicious file. Oh yeah, no, in that case I would prefer the money, haha. Didev says, DL create flashcards after completing a room or CTF? I mean, I do a write-up. I don't necessarily create flashcards. I feel like I'm getting close. So SysOS Master gave us a hint, and SysOS Master has already finished this room. So let's take a closer look at his hint. So he said something like report 1 tgz/root, 1 tgz/root, id echo something something. Well, I mean, what happens if we put this directly in there? Just for fun. And before we do this, let me check on the time. Okay, 30 minutes left, add an hour. Okay. Oh, it ran the system command. it ran the system command. Oh, okay. That's great. Hold on. So we sent one something, and then /root. Why the slash? Move into the root directory and then run id and then echo something. Oops, it did the command thingy. That's true. It ran id. So it ran ID. I guess you need to sneak it into the middle. Because if we run the same thing and it ran ID here, we stuck the thing in the middle. So if we run ls instead. Okay, so it does run the command. So that means we just need to make it run the script. So /temp/malicious.sh. So if it ran it, then we should see our root bash in the temp directory, and it exists. Okay, I think we're finished. So temp root bash -p. Now we're root. All right, the important thing is that we document what happened here, because that was funny. Okay. Root directory. Here's our root.txt here. Traced to the horizon. All right. So we collected the user flag before. I think I extracted the root flag without even getting a root shell. You extracted, oh, okay. So you just catted the flag. So I guess you'd be able to do it from over here. And just, so /root cat root.txt or something. Cat /root something something, right? Whoa. Because we have to avoid using spaces. You can use the space. Oh, okay. So wait. I'm a bit... So, okay. So whatever is here, 1.tgz, could be anything. Okay, let's try to understand how the exploit works. So anything, like one, who am I, ID. Okay, so here it doesn't, oh, it does work, because we see root here. Hold on. So who am I? We sneak it into here. Okay, so the second command is going to be interpreted. The third command is not. So what if we put like a bunch of commands in here then? So ID, ID, ID. So UID group something something. UID, GID groups. So this is the first command. This is the second command. This is the third command. So it'll run whatever is after. So if you do 1 and then ID, it doesn't work. But if you do it again then the first command goes off, but the second command doesn't. All right, let's start doing the write-up. Okay, so automation keyed with the number 9000, which implies it's supposed to be used with the app on 9000. So the app on port 9000 has a health endpoint which we can find with directory busting. Looking at the command reveals why the last one does not fire. So the last one doesn't fire because it's associated with right. The last one gets appended with .tgz. Okay. So we can find this with directory busting, and then on that endpoint, on the health endpoint, we discover another path. So I guess we can record this. So this one was from the health endpoint. So is post jobs export. Can I wait? Let's do the raw data. So this stuff. So this informs us. Oh, wait, why is this all in gray? Should probably put this all in line. This informs us that there is a post request endpoint at jobs export that takes JSON data as a body and requires the automation key as a bearer token. Okay, we're getting close to the end. Can access the endpoint with the automation key we discovered earlier. With this curl command. Something that looks like this. So report something. The response from the server lets us know exactly what command is being run. What command is being run? It's a tar command. So it's something like this. User input here. We can potentially do OS command injection into this command because the file path is not quoted. We find that if we provide what was it, 3 spaces? So do we need semicolons for all these? Or can we just provide spaces? So test, who am I? This doesn't work, or does it? Or test ID, because, right. Okay, so we do need to put a semicolon after each one of these. Could not connect to server. Wait, did I run out of time? Let's check. Sometimes when you complete rooms, they shut down the server on you. Oh yeah, they shut down the machine on me. Okay, let's see if I can complete this without using the thing. Okay, so we find that if we provide at least 3 arguments separated by spaces, the middle arguments will be interpreted as system commands. So Tattletale, I don't understand what you're trying to communicate. So this command will run the ID command. Or this payload, I guess. I think he's trauma dumping. I don't know. Sometimes I really don't understand what's being communicated. So test ID test. So this will run the ID command because the first argument, well, we'll just do test1 and test2. So test1 ID test2. Test1 is appended, well, it has the .tgz appended to it. In the command, and the last and test2 has what was it? So one doesn't have anything appended to it. The third one has something appended to it. Okay. So test1 is appended to the file path. Test2 has .tgz appended to it. The ID argument is run as a command, and test2 has .tgz appended to it. Okay, so we can run this payload to read the flag.txt file in the root directory directly. So the payload is just going to be so test1 cat / root.txt and then test2. Done. All right, well, thank you very much to SysOS Master for the hints. It would have taken me a lot longer without those hints. Much appreciated. Okay, let's try and I really don't want to do day number 12 because it's something that I'm not used to, because we're talking about, what was it? Windows log forensics. But I mean, if we don't finish it, we don't complete the set. We don't complete all the challenges. So let's go ahead and give it a try. What was it called? Like After Hours? After Hours, yeah. Okay, so it's a good old event viewer or something? Kind of. It's not exactly event viewer. It's taking a look at .NET compiled binaries or something like that. .NET decompiled binaries. I've got some stuff here. So it's these objects over here. So I think they're like some sort of like hex dump. They're a hex dump of something. I guess it would be good if we could get ILSpy to work. But the other thing about this, it's reverse engineering, kind of. how much time do we have? I think we've got about an hour and 20 minutes to do this challenge. I don't know how much progress we're going to make. I also need to install ILSpy on my Kali box. Let's see if I can get some good, not event viewer, it's WMI repository dump. Hey Anarchist, nice to see you here. We just finished day 11, so Infinity Pool. That was a ride. I rabbit holed so badly the last time I did it, but we got it done in the end. Okay, so ILSpy Kali Linux install. Please tell me how to do it. Just saw the end, yeah. Okay, you can install the command line decompiler tool ILSpy command on Kali Linux by installing a supported .NET SDK and running .NET tool install global ILSpy command. Okay, well, let's see if this works. .NET tool. .NET tool. Wait, do I have that installed? Oh, I do have it installed. That's funny. You don't need ILSpy for day 12 until a fair bit later. Yeah, I mean, we've been trying to get the original file back for a while, so maybe we won't install it immediately. Because let's map out what we found so far. So this is day 12. Let's make a file for this. Okay, so Anarchist says, I kind of went deep on the WMI format for day 12, but you don't really need it. Okay, so this is day 12. Okay, let's get all of our required information. So the concept is what do we call this? System artifacts. So WMI repository dump. WMI, like I guess Windows, WMI repository dump enumeration. Flare WMI has a lot of useful tools for this. Note the above hint. The above hint. Flare WMI, Mandiant. I was just taking a look at Flare VM earlier today because I got reminded of, what was it, the Commando VM yesterday when we were talking about Windows and, like, you know, pen testing stuff. .NET binary decompilation. Why is that considered a spelling error? Okay, so we download the task files and unzip them. There are 4 files. What, 5 files? Quick, someone decompile the spelling checker for that. Decompile. So decompile works, but decompilation doesn't. Okay, well, so index BTR and then a bunch of like mapping files and then object data. Okay, so the important part of the challenge is that we try to learn as much as we can about what's actually going on and not be super focused on getting flags. Anarchist says the Flare WI will pass the WBEM dump. The stuff in Python CIM is a newer version of it, which has a bunch of examples and outlines principles. So this, I mean, Windows forensics is something that is pretty foreign to me. So I've been having a hard time with this. Like, operating system log forensics is kind of foreign to me in general. I need to get used to it. Tattletale, do you want Hack the Planet? I can give you Hack the Planet. Here.
Hack the planet! Hack the planet! Shut up and get in.
Denger Gaming, I recognize your name. Hello, nice to see you here. How are you doing? So where do we find the weird PowerShell commands? So I think we found the weird PowerShell commands in the objects.data file. So you ran strings on objects.data, and we searched for PowerShell. So we found that there were PowerShell commands being run, and we can make sure we're not looking at multiple PowerShell commands by running like sort and then unique. So there's only one PowerShell command that's being run. It's this one. It's being sent through base64. Yeah, this is there's a base64 encoded payload in here. Okay, so let's record this. I don't remember this part in Hackers. Which part? The part where they say hack the planet, or which other part? The one where they do digital file forensics? Maybe not. Okay, there's reference to a PowerShell command. In objects.data. The hack the planet part? Oh yeah, that's when oh, what was his name? Was it Crash Override? During the final setup where they hack the Gibson and get caught. Yeah, that's when the guy gets caught. Okay, how much time do we have? We can do like an hour and 10 minutes. So like 70 minutes. Oh, Zero Cool. He's got like the main character has two pseudonyms. So it's Zero Cool and Crash Override is the guy getting the floppy. Hold on. Hackers movie cast. Okay, Dade Murphy. Wow, Johnny Lee Miller looks different now. So all these people look really different now. Hacker names. What were their hacker names? What were the hacker names in the movie Hackers? Okay, Crash Override and Zero Cool, aren't they? Yeah, Crash Override and Zero Cool are the same guy. What are we talking about? Skater Die says, let's see, it was the big company crying wolf, but their IT guy was the one setting them up. That guy yelling, hack the planet. Matthew Lillard looks the same, does he? Yeah, kind of. He kind of looks the same. Serial killer. Yeah, Matthew Lillard was serial killer. And I can't remember the names of the other guys. Zero Cool, Acid Burn, Serial Killer, Lord Nikon, Phantom Freak, and some guy named Joey. And the Plague. This was the bad guy. Okay, so what we need to do is we need to grab the base64 encoded information, and then we turn it back into a PowerShell command. So it looks like this. When we decode the PowerShell payload, it turns out to be another PowerShell. It's a PowerShell script. It turns out to be a PowerShell script. PowerShell. Okay, not now. In 2026, he was the serial killer in Scream. Oh, that's true. He was also a serial killer in Scream. Although that's kind of a spoiler. So the script looks like this. I mean, I'm not super familiar with PowerShell, but there's a bunch of methods being run here. So I think deflate stream and then from base64 string. So this is some data. New object is considered like a keyword, right? In PowerShell. Taldale says, went to a meetup last night and another hacker was laughing about hacking a payphone. They're playing the movie in a bar and restaurant. I mean, the hacking has taken a lot of different forms. Back when computer access wasn't so popular, people hacked the phone system because the phone system was something that everybody interacted with. Okay. So deflate stream and then convert from base64. New object is a built-in PowerShell command, like a built-in function in Python. So new object, I guess, is just creating an object. So create an object, and the object is this. So in this case, new object is IO memory stream. Okay, so this is a PowerShell script. So I guess we need to talk about the PowerShell script. The script takes in. Well, let's try to take this apart like one line at a time. I'm not super proficient with PowerShell, so I'll try to get our good friend the AI to explain what's going on. Oh man, Perplexity has been not doing it for me lately. So we'll do Gemini. Okay, please explain this PowerShell script one line at a time. Okay, here's a breakdown. The script is a classic fileless payload loader. Fileless payload loader. Okay, it queries WMI, Windows Management Instrumentation, for stored data, decodes and decompresses it entirely in memory, and then executes it as a .NET assembly without writing anything to the hard drive. Okay, so it's wait, I think SysOS Master was talking about this. He was talking about reflection. So running stuff in memory without touching, so like, what do you call it again? Like touchless malware? Good luck, Skater Die. Hope you have a good one. It queries WMI, Windows Management Instrumentation, for stored data, decodes and decompresses it entirely in memory, and then executes it as a .NET assembly without writing anything to the hard drive. So file equals WMI class root something something. So accesses the WMI class in Win32 hardware telemetry under root CIM version 2 and retrieves the value of the config data property. This value typically contains a base64 encoded compressed payload. Okay, so O equals new object IO memory stream, creates a new empty in-memory stream. This will be used to hold the final uncompressed binary data. Yellow hacking devices. I'm not super familiar. What is the yellow hacking device? Probably something from like Hack5. Let me do a quick search. Yellow hacking device. The Flipper Zero? Are you talking about this thing, Tattletale? Hold on. All right, let me take a little bit of a break. And you know what? We'll put on my favorite video. These are the fledgling Stellar Jays. We'll be back in about 60 seconds. I just need to take a little water break. I could watch these little guys all day. They're just having so much fun. Okay, let's get back to the hacking. Creates a new empty in-memory stream. This will be used to hold the final uncompressed binary data. Okay, D is IO compressed deflate stream, IO memory stream convert from base64 file. So converts the base64 encoded string file into raw byte arrays, wraps it in a memory stream, and then creates a deflate stream configured to decompress the data. Okay, so B is a new object bytes, allocates a byte array buffer with the size of 1024 bytes, so 1 kilobyte. This buffer acts as a temporary holding area while reading chunks of the decompressed data. R equals d.read reads up to 1024 bytes from the deflation stream into the buffer. It returns the actual number of bytes read, saving that count into the variable R. Okay, and then we've got a loop. So while R is greater than 0, starts a loop that continues as long as there are still bytes being read from the stream. So R greater than 0. O.write inside the loop writes the chunks of decompressed bytes stored in the buffer into the master memory stream. So that's O. R equals d.read inside the loop reads the next chunk of 1024 bytes from the deflation stream, updating R for the next loop iteration. So finally, reflection.assembly load to array entry point invoke out null. So it takes all the bytes accumulated into the memory stream, loads them directly into the memory as the .NET assembly, finds the compiled program's main entry point, invokes it, executes it with empty string arguments, pipes the output to out null to hide any return values from the console. Because of how the script retrieves data from WMI, decompresses it into RAM, and executes it via .NET reflection without touching the disk, patterns like this are frequently analyzed in cybersecurity as fileless malware loaders. What is the context or goal behind exploring this script? Okay, we need to find where the payload, where the bytes, or I guess the base 64 bytes would appear in the WMI repo the WMI repo dump that we're investigating. So then in WMI repository dumps, the base 64 bytes won't just appear as a clean text string, because WMI stores objects in the proprietary binary database format. Data is structured into records containing class definitions. Okay, so where to look in the dump? The class name Win32 hardware telemetry. So I think we did do this. We found this, we looked for this in the index.btr. And we grepped out for this pattern. Oh no, it was the object's data again? I guess it was the object's data. So we looked for this and then we grabbed the surrounding 10 lines. And we found a bunch of base 64 encoded data. So what we can do here is we can do sort and unique again. Do we need 10 lines? Maybe we only need like 2. No, we need more than 2. Maybe 5? Yeah, okay. So if we grab 5 lines, then we can see the base 64 encoded data. Let's talk about it. The script takes... How do I explain this? Because I just read this. I'm not really an expert. So look for the class name in the dump. Win32 hardware telemetry. Preferably with words. Probably. Maybe not just symbols, right? Fileless payload loader. Fileless payload loader. It queries WMI, Windows Management Instrumentation, for stored data. So, I mean, my question is, what is this stored data in WMI instrumentation? What's the stored data in WMI that would be classified as malware? Not just with grunts, optionally with diagrams. Okay, so the script looks for data in the WMI, was it telemetry? Win32 hardware telemetry class. But what data located there would be useful to run as malware? So it's not a built-in legitimate. Win32 hardware telemetry is not a built-in or legitimate operating system class. It is a custom artificially created oh, okay. So hardware telemetry is not. This is something that looks like it might be legitimate, but it's not legitimate. So adversaries or simulation exercises use this technique to turn the WMI database into a hidden storage locker. Storing data inside the WMI repository offers several strategic advantages for malicious payloads. So this is a custom class that that's being used to store data. So why store data in a custom WMI class? Evades file-based scans, traditional antivirus, continuously monitor the file system. Because the payload lives entirely inside the binary structure of the WMI database, it bypasses standard file scans. Okay. So in short, nothing natively useful to the operating system lives in Win32 hardware telemetry. The class exists solely as an evasion container designed to smuggle an encoded binary payload past security controls. That's interesting. Takes the contents of a WMI, what was it called? So a WMI class called Win32 hardware telemetry. Which is not a legitimate Windows WMI class. So it takes the contents of the WMI class and then obfuscates it. Obfuscates it using using compression. So that would be the deflate stream. And encoding. So that's the base 64. From base 64 string. It's not obfuscating it, it's decoding it. It's not obfuscating it. So from base 64 string, so why is it required that they encode it into base 64 in the first place then? Maybe they need to base 64 encode it in order to put it into some place that it doesn't accept bytes. Let's just call it modifies it. Modifies using compression and encoding. Okay, or de-obfuscating, kinda, but the base 64 is just because you can only store strings in WMI, and compressing it makes it smaller. Okay, that makes sense. Okay, so deflate stream and from base 64 string are applied to it. Then the data is read into a buffer using a loop. And where's it put into? Oh, it's put into the reflection assembly. So read into a buffer using a loop, then executed using reflection. So which system uses that reflection? Decompress on the fly via deflate stream and injected straight into memory using .NET reflection. So it's injected into the memory and then executed from the memory? So this is .NET reflection, okay? Read into the buffer. The data is read into the buffer using a loop, then injected and executed. Injected into memory and executed using .NET reflection. Or at least I think that's what's happening. So the next step is to locate the base 64 encoded data associated with the Win32 hardware telemetry class. Okay. So this is where this command comes in. So we look at the object data, we look for this class. IBDev. IBDev, hello, nice to see you. Hope you're having a good day. So this command, we find the base 64 encoded data. and we have to revert it back into a .NET binary. This involves base64 decoding the data. Yeah, how is the teacher today? I'm doing okay. I'm learning a lot of new stuff today. Thank you very much, IB Dev. Thank you. Okay, so base64 decoding the data and then inflating it. So base64 decode the data, then inflate the data since it was deflated before. But how do we, I mean, do we use, we tried to use CyberChef. We tried to use CyberChef to do this, but it didn't really result in anything that we could use. So maybe what we should be doing is we should be using Python. Or maybe what we should be using is we should be using PowerShell, because PowerShell was used to create the thing. Yeah, using PowerShell is probably the best way to do it. Okay, so we find Python does deflate compression. Python does it. Okay, I mean, what's the easier way to do it? Is it easier to do it with CyberChef, or is it easier to do with Python, or is it easier to do with PowerShell? So normally in these kind of situations, I default towards the tool that was used to do the operation to undo the operation. SysOS says I used PHP. Oh, well, I mean, whatever tool works for you, I suppose, right? Whatever tool gets the job done. Okay. I tried PowerShell first, it did not work. PowerShell didn't work out for you? Okay, let's ask Gemini, maybe it has an idea. So if we have the base64 encoded data from the Win32 hardware telemetry, class, what tool is best suited to reverting the data back into a .NET binary? Okay, Anarchist says deflate compression is a common standard. In Python, it's the zlib library. The PowerShell wanted to execute the payload. I mean, I guess that's a danger of doing it on a Windows machine. I guess you could have used PowerShell from Linux, and it would have been less of a threat. Okay, the best suited tool for this task is a short Python script using its built-in standard libraries, base64 and zlib. Okay, so Gemini agrees with you, Anarchist. Raphael Tani, thank you very much for subscribing on YouTube. Thank you. Okay, tech question: is reverse image search engine, are these engines trustworthy to use? I want to find where my pics are being used. Trustworthy to use? I mean, anything you feed into a reverse image search engine is probably going to keep your data, unless it says otherwise. So I mean, if you're talking about like Google reverse image search, that's probably like the most well-known one. If you want to find out where your pics are being used, you'd probably use something like Google reverse image search. I'm not super familiar with any other commonly used reverse image search engines. Okay, I'll finish watching later. Thanks, Budweiser. Sure, I'll give you a Budweiser for the road. Tattletale.
Bud. Wise. Bud. Bud. Wise. Bud. Wise. Bud.
Okay, the gzip command line tool might even do it. Although it's just a compressed stream, not a proper gz file, so it might have issues. Okay, I mean, I guess we can just use Python, because Python can do anything, right? Python can replicate the exact transformation safely offline without executing any code. So we just have to import base64 and zlib? Sure. Let's write a script. We'll do it over here. Revert.py. So I guess we'll do data. We'll call it binary data. It's just a big string, a big base64 string. This stuff. Okay, so we got our binary data, and then B64 decoded. Decoded data is binary data was like base64 dot B64 decode binary data, right? I don't know if this is the exact syntax. I guess I'll find out in just a sec. Base64 payload is this thing. Try. Compressed bytes. Oh, okay. So I guess base64.b64 decode base64 payload. So decode base64 to raw compressed bytes. I got that part right. I'm so happy about that. Decompress using deflate. So decompressed binary equals zlib.decompress. So what is this option over here? zlib.maxwbits. So decoded data, decompressed data is going to be what? Comment tells you what the option does. zlib max w bits handles raw deflate. Raw deflate streams without headers. Okay. Then we need to write it out to a file. So the first step is decoding, the second step is decompressing, and the third step is turning it into a file. So output file name equals something something. I'm a bit disappointed we weren't able to do it with with CyberChef, but maybe I can figure it out later. So output file name extracted payload.dll. How do we know it's a DLL and not an exe file? Payload.dll, okay. With open output file name wb as f.write decompressed data. Oh, I'm in the wrong day. Hold on. Let me copy this over. Okay, what was this? The risk of them having my uploaded photo. Okay, DLL is what you would store a bare assembly in .NET. It doesn't have P headers, Windows equivalent of ELF. Okay, so, well, I mean, I'm learning a lot about Windows file extensions. I regret uploading my driver's license to some random JPEG to PDF conversion website. Well, everybody has to be careful with their data, for sure. Okay, you can use XXD to check the binary data bytes header. Yeah, I guess after we're done, we can do that. So we'll run the revert.py script. Base 64 has no attribute B. Oh, I typoed it. Nope, I didn't typo anything else. Okay, so now we've got payload.dll here. Don't worry about it, the photo wasn't that bad. Wait, nullsec, how do you know? Do you have the photo? Okay, so xxd on payload.dll. Ooh, most of this is blank. Oh, interesting. MZ. So doesn't MZ what are these magic bytes? So the resulting binary file has this file header. So the file header confirms that you have successfully extracted the payload. So MZ and ASCII are the standard bytes for a DOS PE portal executable file header. So doesn't that mean that this is a universal signature for Windows executable files? Oh, okay, so DLLs and executable files both have this file header, huh? Because the original PowerShell script loaded it using this, the extracted binary is almost certainly a .dll .NET DLL or executable. So it could be either, right? Since you have a valid PE file on disk, you can safely analyze its contents without running it. Decompile and inspect code, .NET decompiler. So open the file in dnspy or ilspy. What's the difference? What's the difference between these two tools? I'm sure there are some sort of difference. Okay, because it's .NET assembly, these tools will let you read the original C# or VBNet source code. Okay, so I guess we've got. Let's document what we've done so far. Then we'll move on to using the decompiler. base64 decoding the data, then inflating the data, then writing that data to a file. This Python script does the job. Does OP leave the house often? I am the real guy. Hello, nice to see you here. Hope you're having a good day. Okay, let's get the contents of that script. All right. Now we have a .NET binary to decompile. Looks like the .NET has some XML. I mean, let's just take a look at some of the strings. My application.app. This program cannot be run in DOS mode. Okay, I'm going to need a lot of help. I'm going to need a lot of help from various sources because I do not, I am not very good at C#. Although C# is kind of similar to Java, right? And I'm also not very good at Java. Okay, so ILSpy, we can install it now. So .NET will install global ILSpy command. ILSpy command failed to install. You're attempting to install a preview release. Okay, C# is like Java, right? Because I also suck at Java. Freely interpreted from the Shy Hat. C#, it's like Java, right? Because I also suck at Java. Yeah, well, you know, I am at least a little bit familiar with Java. Much less with C#. I know they're both really, really clunky programming languages. Okay. Installed an ASP.NET Core HTTPS development certificate. To trust certificate, run .NET dev certs HTTPS trust. Windows and macOS only. Okay. So we weren't able to install the thing. Oh, okay. Maybe there are some prerequisites we forgot to do. Install the required .NET SDK. Matching the latest requirements on the official ILSpy GitHub repository. Install the global tool. Verify that the installation works. Okay, avoid what? ILSpy, so this is the GitHub repository. Your .NET needs to upgrade. Your .NET needs to upgrade. How do we upgrade only the .NET? Hey, it's OreoByte. I wonder what happened to OreoByte. I haven't talked with that guy in a while. So OreoByte, let's recommend his channel. So OreoByte does a bunch of Windows focused, I'd say, like Windows focused security videos. And I used to do collaborations with them. Hold on. Here's his channel. Thank you very much for the subscription on YouTube. Fath Muiz, thank you. What's he been publishing? Oh, he hasn't published anything in a while. Tooling to help hunt down POCs for vulnerable CVEs beyond search exploit. Yeah. These thumbnails are something else, though. Okay, build ILSpy on Linux. Let's take a look. Okay, so git clone the repository. So .NET SDK version this thing. Couldn't find. This is the right GitHub repository, right? Let me just make sure it's the right one. They might have instructions for installing on Linux here as well. Our .NET tool for Linux, Mac, Windows. Check out ILSpy command in this repository. .NET tool install. So this is what we were directed to. .NET tool install global IL. Okay, so we tried doing this. And to people who have solved this in chat, so Anarchist and SysOS Master, which tool were you using? Were you using ILSpy CMD, or were you using the GUI version of ILSpy, or were you using something else? Let me know. Because I'd rather use the GUI version. GUI version, okay. So the gist over here suggests that we do git clone. We'll do these one at a time and see if we can get this working. So git clone this repository. Whoops, gotta spell the word clone correctly. Already exists. Oh yeah, okay, we already git cloned it. Okay, let's see. Anarchist says, I use the JetBrains.peek, a full-on decompiler. Maybe try an online version of ILSpy running in Wasm. Otherwise, you could just you're just looking in the dark. Okay, is there an online decompiler that we can use? Because that sounds very useful. It's called Cluzo.net. Let's take a look. Interesting. Okay, let me take a look at this. So drop your assemblies here. .NET decompiler and assembly browser using client-side decompilation. How does it work? Decompile .NET assemblies directly in the browser using WebAssembly. Prevent sending sensitive assemblies to any server. I mean, I don't really care about sensitive assemblies, but sure. Do we just drop in our file here? Temp HF day 12 payload DLL. Okay, it's here. Decompile and then delete. Okay, decompile. Now we can do what? Open, download. I guess we'll open it. Oh, it's thinking. All right, I'm going to take a sip of water. I'll be back in just a sec. Guess it's taken a while to initialize. That's fine. I can close out some of these windows I'm not using. So, Anarchist, have you used much of Cluzo before? Nope, never used. Well, hopefully it turns out okay. Still loading. Nope, we'll just wait for a little while longer. Don't need this anymore. Okay, the turnip says if you end up needing .peek, it's pretty easy to use. .peek just looked like an interesting approach. Others looked a little bit dodgy, but it looks a little bit heavyweight running a full VS Code IDE in the browser. I wonder if there's any other .NET decompilers that you can access online. .NET decompiler online. Dogbolt. You can use Decompiler Explorer as an interactive online tool to decompile .NET and other binaries in your web browser. Decompiler Explorer. So this is Dogbolt. Okay. And wait. Uploaded binaries are retained. Oh, okay. Doesn't bother me none. Okay, so I mean, this isn't .NET specific, but does it need to be? It also doesn't seem to be reading it very well. Okay, so the Cluzo.net still hasn't come back to us. Maybe I can try loading it again. Nope, it's unresponsive. It's stuck. Okay, decompiler.com, Cluzo, Decompile Explorer, which we see here, online.dat decompiler.com allows you to upload .exe or DLL files to convert CIL bytecode back into C# source code online. Okay, more options. So drop exe or DLL. Okay, can take everything. I wonder if one of these is going to try to redirect me to some dodgy page and then give me, you know, make me click on a link, steal my sessions, all that good stuff. Okay, so the first one to work gets the prize. Wait, are these the source code files? After hours okay, after hours, that lines up. So program.cs. So let me download these files and then we can look at them more easily. So program.cs, and then program.cs, properties, assemblyinfo.cs, and then payload csproj. Okay, we'll download this one, and then we'll download the last file. Okay. So we got the 3 files. We'll just copy them over to our current directory. We'll make another directory for this. Decompiled. We'll just call it decompiled. And we'll move the stuff into here. So what were the names of those things? Payload something something. The next one was called assembly info and then program. Thank you very much, Hack Smarter, for raiding into the channel. Welcome in, raiders. My name's the Shy Hat. I do cybersecurity content on Twitch and on YouTube, and let's give a shout out to Hack Smarter. Hack Smarter has his own cybersecurity education platform over here. Hack Smarter, what were you all getting up to on the channel? Okay, the CS project and assembly info are just project files needed for compiling. Only needed. But yeah, were you guys doing a lab over in Hack Smarter or a range? Giveaway and Q&A. Oh, awesome. AMA and giveaway tonight, and a few subs to Hack Smarter. Yeah. So what, so Hack Smarter, could you tell me which ones of your recently released labs that might pique my interest? So maybe Casino or sysadmins. Which one did you find really fun? Let me know. Actually, I think we're going to be doing second. We're going to be doing second on Friday, because I need to practice my AWS hacking stuff. Casino, do Casino. Oh, yeah, okay, that's great. I will keep that in mind. I'll keep a little note. Second is a good one, but Casino is great web app one based on DEF CON. Based on DEF CON, you say? That's awesome. So we'll definitely check out casino. Maybe next week. Next week we'll do casino. This week we're doing second because it's in the schedule over here. So the last thing we're going to be doing on Friday is second from Hack Smarter. But welcome in, Raiders. Yeah. Let's do some Hack the Planet. There you go.
Hack the planet! Hack the planet! Shut up and get...
So right now we're trying to decompile. Well, we decompiled a program, and what we need to do is we need to take a look at this C# code to try to get some information about what's actually going on. This indentation is really annoying. Okay, let's see. John Doe says if you do casino before September 28th, you can win a voucher for OSCP course and certs. Oh, that's awesome. Yeah. Nice. More AWS labs coming very soon. We'll make a bunch of them for free for folks. Yeah, that's I'm happy to hear that. But I hope you guys had fun. Oh, wow. So many new viewers. Jay Soberbeck and Lansy Kevin and John Doe, Zaba, SH42, D&D Chemist. Thank you very much for rating on in. Thank you. But are you guys good at doing C#? I'm not. I'm very bad at it. Okay, so it looks like we got some sort of long string happening here. So net user patch something something. Let me get the entire string. So this looks like some base64 encoded stuff. Let's copy that really quick. C# is a bit of a nightmare. Well, it is what it is. Echo base64 decode. Hey, there you go. We got the flag. Okay. All right. Let's go ahead and, well, let's just finish doing the write-up. Okay, so we have a .NET binary to decompile. We used a very handy website to decompile the thing. So it was this one over here. So decompile.com. And it was much easier than installing your own decompiler. So we use this website to decompile the binary. Why does decompile come back as a spelling error? I guess it's a technical jargon, huh? Okay, so after uploading the binary and decompiling it, we can download the source files. The one we need to pay attention to is called program.cs. I guess it's not always called program.cs, or is it? I'm not sure. I don't code in C#. Okay, let's get the contents of program.cs. Can't, that's just a name. It's like application.c. It means nothing. Okay. It's not like a standard naming scheme. This is the line we need to pay attention to. So process start info arguments blah blah blah. The base 64 encoded string is the flag for the challenge. Okay. All right, let's submit it, and then we'll be finished with this challenge. Maybe we can take a sneak peek at, well, I guess I guess not. I guess we don't have enough time to really take a sneak peek at the next thing. But there's only a couple more challenges to go. Okay. All right, let's talk about where we might be going off to next, because I'm running out of time for this stream. And who's on infosecstreams.com? Thank you, Zaba. Thank you. I couldn't have done it without help from my friends. Dika, hello, nice to see you here. Okay, BlazeBits is on. Awesome. Let's check out what he's up to. So BlazeBits is a working penetration testing person, and he's also very, very cool. And he's got a very, very awesome beard. Are we friends? Are we friends? Yeah, of course we're friends. Why wouldn't we be? Okay, so he is working on some cybersecurity news and Q&A. We'll be back on Friday, but we are all friends. We are all friends, of course. Okay. Let's start the raid. No worries. Okay, let's do the raid message. So OSFrog, hip hop hack, OSFrog, if you could give this message, I'm glad to be friends with anyone, so am I. If you give this message when you arrive on this channel, I would be very appreciative. Stoic Booty, thanks for the stream. That's a great name, Stoic Booty. Hip hop hack. Okay, we're going to be back on Friday. We're going to be doing more hacking stuff, but I hope you have a great rest of the week. All right, everybody, thank you very much for coming today. And HackerFrogs out in 5, 4, 3, 2, 1. See you on Friday, everybody.